I'm Brian Farrell, and welcome to PACE IT's session on Windows operating system features. Today we're going to be discussing 32-bit versus 64-bit operating systems, file structure, some core components of modern operating systems, and the upgrade paths for Windows. And with that, let's go ahead and begin this session. So we're going to begin with 32-bit versus 64-bit operating systems. And a lot of this is dependent upon the hardware that you have. If you have a 64-bit processor, then you can install either a 32-bit or 64-bit OS. But if you only have a 32-bit processor, guess what? You only get a 32-bit operating system. Now, a 32-bit operating system, you can only have a max of 4 gigabytes of RAM. That's all that's addressable. You can only run 32-bit software. 32-bit operating systems were the most common operating system in the past, and it's not quite as robust as 64-bit. 64-bit operating systems allow you to address a maximum of 192 gigabytes of RAM. Man, that's a lot. You can run both 32-bit and 64-bit software. It is becoming more and more common as we move into the future, and it's far more robust and it's much faster at multitasking than 32-bit operating system. Now here's a slide that shows how much RAM each version of Windows will address, and also how many processors. If you notice, Ultimate and the Pro versions are the ones that are best if you want a powerhouse system. Now let's move on to file structure, and we get to begin with FAT. FAT stands for File Allocation Table. It's how files and data are distributed on the hard drive. It's legacy and was developed in 1977. The original deployment of it was 8-bit. It had limited capabilities. Max partition was 4 gigabytes. Max file size was 2 gigabytes. FAT32 came along and it was a vast improvement. It's a 32-bit implementation. Its common usage today is in removable media, like USB flash drives and camera memory cards. It had much better capabilities, but it's still limited in its usability. Max partition is 32 gigabytes and a max file size is 4 gigabytes. And it offers no file level security. That wasn't good enough for Microsoft, so they moved on to NTFS, New Technology File System, and it is proprietary to Microsoft. It's more secure. It allows for native drive encryption, both file and folder permissions as well. It's more efficient than FAT32 as well. You can also use native compression. It has more fault tolerance. It recognizes and recovers from some disk errors without the user having to intervene. It also allows for larger capacity. Let's move on to some core components of Windows operating systems. And we begin with administrative tools. All versions come with administrative tools. Those are located on the control panel, and they allow you to configure and troubleshoot your system. All Windows operating systems have some backup program that comes bundled with them. Actually, it's built right into the operating system. Then there's compatibility mode. Especially in Vista, in Windows 7, and Windows 8, sometimes they have difficulty running programs that were developed for Windows XP. You can run those in compatibility mode. All versions have an event viewer. That way you can check system logs for errors and events. Some versions allow you to join domains. That's much better networking than work groups. Offline files are also available in some versions. That means that you can download a file, take it home on your laptop, modify it, and when you go back to work and you plug into the network, it gets resynced with the file on the server. It allows you to take it, work on it, change it, bring it back, and it will make sure that it stays up to date. All systems have system restore capabilities as well. This allows you to roll back to a previous state, and it does not affect files or programs. It really helps recover when an installation of a program goes bad. Then there's Windows Defender. It protects the user against malware. Then there's Windows Firewall. It's a standalone software firewall that protects a PC from virus attacks. Then there's Arrow. This is for the desktop. It's a graphic enhancement that was introduced in Windows Vista and improved upon in Windows 7. Then we have User Account Control, UAC. It's a security control introduced in Windows Vista that separates administrative control from normal user accounts. Sometimes it's a bit of a nanny, but get used to it. Then there are gadgets. Gadgets are mini programs, think apps, that can be added to the sidebar in Windows Vista and to the desktop in Windows 7. Then there's BitLocker. BitLocker is available in some versions. It allows for whole drive encryption. One of the things that I will say is you can either compress your files or compress your drive, or you can encrypt your drive, but you can't do both. Microsoft introduced Shadow Copy. It's used by Windows operating systems to create a copy of a file even when it's in use. And it can be configured to store the copy in almost any location. It's a great way to roll back what you're working on. Microsoft also introduced ReadyBoost. ReadyBoost is a way of using fast external storage, usually USB drives, as additional RAM, which can boost system performance. The external storage must be configured to be ReadyBoost ready. Let's talk about the upgrade path. Upgrade is moving from one edition or version of an operating system to another, and all programs and files are retained. The old system information is retained in a Windows file called windows.old. Upgrade paths. XP can be upgraded to Vista. Vista can be upgraded to 7, but XP cannot be upgraded directly to Windows 7. If you're running 32-bit, you can only upgrade to 32-bit, and if you're running 64-bit, you can only upgrade to 64-bit. Also, you can only upgrade to the same version or higher. That means if you're doing Home Premium, then you can go Home Premium and higher. But if you're going from Ultimate version, you've got to go Ultimate. If you're moving to a new physical PC, you might want to consider Windows Easy Transfer. It's a consumer-grade tool that makes the transition easier. It pulls the information from the old machine and deposits it on the new machine. For the enterprise, Microsoft introduced User State Migration Tool. It's a great tool that can highly automate the transition from one physical machine to another. Now, that concludes this session. We covered 32-bit versus 64-bit operating systems. We talked about file structure and some core components of Windows operating system. And then we also talked about the upgrade path. Now, on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing more. Hello, I'm Brian Farrell, and welcome to PACE IT's Introduction to Microsoft Operating Systems. Today we're going to be discussing Windows XP, Windows Vista, and Windows 7. And then there will be a brief discussion on the systems requirements for each of those operating systems. And with that, let's go ahead and begin this session. Of course, we're going to begin with Windows XP. Windows XP was introduced in 2001, and support for it ended in April 2014, so it's at end of life. Windows XP had 4 different editions. XP Home, which was for the home user, was very basic and only had basic capabilities. XP Professional was for the business user. It added file encryption, remote desktop access, and users could join domains. XP Media Center was targeted to the home entertainment market. Users could watch television, watch DVDs, listen to music, etc. Then there was XP 64-bit Professional. That was XP's only 64-bit edition. It added the capability for more RAM and power, but it also required a 64-bit processor in order to install the operating system, and they were not that common back then. Now let's move on to Windows Vista. Windows Vista was introduced in 2007, and support for it ends in 2017. Windows Vista has 5 different editions. Vista Home Basic is the stripped-down version. Vista Home Premium maps to XP Media Center. Then there was Vista Business. In this edition, users can join domains. File encryption was added, and Microsoft also added offline file capability. Vista Enterprise was only available to Microsoft Software Assurance customers, MSA customers. The added benefit here was BitLocker drive encryption, which is whole drive encryption. The last edition is Vista Ultimate. Every feature that's available in any edition is available in Vista Ultimate. Now let's move on to Windows 7. Windows 7 was introduced in 2009 and support for it ends in 2020. Windows 7 has 5 different editions. The basic edition is 7 Starter. It only comes in a 32-bit version, and the maximum amount of RAM that is supported is 2 gigabytes, but it is very lightweight. It was good for netbooks and tablets. 7 Home Premium was for the home market, and it added Arrow to the desktop. It also had home groups, which is an easier way of networking than work groups, and Windows Media Center. 7 Professional was for the basic business user, and the main benefit here is that users can join domains and are not just left with home groups or work groups. Then there was 7 Enterprise, only available to MSA customers, and again, it included BitLocker drive encryption. Last but not least is 7 Ultimate. Just as with Windows Vista, the Ultimate Edition has every feature available to every customer. Now let's discuss the system's requirements for each of those operating systems. The requirements for Windows XP were fairly minimal, at least by today's standard. For the processor, the minimum requirements was a processor that could run at 233 megahertz at the minimum. Microsoft did recommend that the processor be a 300 megahertz or faster processor. The RAM requirements for XP required that there be at least a 64 megabit minimum. Microsoft did recommend 128 megabytes or more. The hard drive requirements for XP were fairly minimal. You only needed 1.5 gigabytes of space. But back in 2001, that was actually a fair amount of space. The introduction of Windows Vista really ramped up the requirements for an operating system. On the processor side, Microsoft said that the minimum requirement was an 800 megahertz processor, although they did recommend that the processor be able to operate at 1 gigahertz or faster. The RAM requirements also ramped up substantially. The minimum amount of RAM was 512 megabytes, with 1 gigabyte or more recommended. For the first time, Microsoft required a minimum hard drive size, and that was 20 gigabytes, with 15 gigabytes of that being free. Although Microsoft did recommend that the hard drive be at least 40 gigabytes. Microsoft added video requirements to Vista as well. Your video hardware had to have at least 32 megabytes of RAM to run Home Basic, and all other versions required 128 megabytes. As time marched on, and so did the operating systems, so did the requirements. When Windows 7 came out, Microsoft required that the processor run at least at 1 gigahertz or faster. On the RAM side of things, if you were running a 32-bit system, Microsoft said that you needed at least 1 gigabyte of RAM and 2 gigabytes of RAM for a 64-bit operating system. Although I would recommend that you at least double those for those operating systems. On the hard drive side, Microsoft required 16 gigabytes of hard drive space for a 32-bit installation and 20 gigabytes of space for a 64-bit installation. Microsoft again upped the ante on video with Windows 7. Now you didn't have a RAM requirement, but you had a capabilities requirement. The video card or video hardware had to be able to support DirectX 9 and WDDM 1.0 or higher. Now this concludes this session on Microsoft operating systems and requirements. We talked about Windows XP, Windows Vista, and Windows 7. And then I gave you a brief rundown on the basic systems requirements for each of those operating systems. Now on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on installing and configuring operating system. Today we're going to talk about installation media, installation method, and types of installation. And with that, let's go ahead and begin this session. We begin with installation media and method. I rolled those two into one just because it makes a lot of sense. So for installation media, the first thing that you can do is an installation of the operating system using hard media. Think CD-ROM, DVD, USB, portable hard drives, so on and so forth. Another type of media that you can use is the network share. The operating system is available over the network and the media is not in the technician's hands. And finally, in the media, you can use an image. The image can be on physical media or it can be over the network. A base or preferred operating system has been created and it is stored in a file. This is best for mass deployments. For installation methods, we go back to the physical media. That's the classic method. Power up the system, install the disk, and then sit around and wait. For this, the technician needs to have the media, and this is best suited for small deployments. Now let's move on to network deployment. For network shares, the PC downloads the operating system from a server. This requires more setup as there is more hardware that is involved. The PC gets fired up and it requests a copy of the operating system upon boot up attempt. This is best for larger deployments. Then there is the image. The standard image is used in multiple cases. This requires some specific procedures, but it can also speed up some larger deployments as all the images are the same. Now let's move on to types of installation. So that first off, there's the clean installation. This is taking a machine that doesn't have an operating system or does have one and putting a brand new one on it. This is a fresh start. Contains the most steps, but it also affords you the most flexibility. Then there is the upgrade installation. This updates the operating system with minimal interruption. It keeps all files and programs the same, but you need to make sure that you're following the proper upgrade path. Then we have the repair installation. This is used to fix a broken operating system. The system is treated like an upgrade, and it requires the license key as well. Applications and data are moved to the Windows.old file. Then there's the multi-boot installation. This allows for multiple operating systems to reside on the same machine. Each operating system must have its own partition. The user selects which operating system to load at boot. Then there's an unattended installation. This is where the technician uses a special script file to provide responses to systems variables. Then there's the remote network installation. The installation files reside on a remote server, and it requires a DHCP server, a DNS server, a domain, and a PXE client, a PXE client. That's a pre-execution environment client. And it also requires the proper operating system's license. So now let's talk about image deployment remote. It is very similar to a remote network installation. An image, by the way, is a snapshot of a given system at a given time. And using an image can lead to some problems, as in multiple security identifiers. Networks and systems don't like that. If you use the sysprep tool after creating the reference system, you can strip out the SID before you capture the image. Now let's talk about image deployment local. This is where you place the image onto a hard media, as in a DVD, USB, portable hard drive, and you go and visit each machine deploying the image one by one. Now that concludes this session. We talked about installation media and methods and different types of installation. On behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on installing and configuring operating systems, Part 2. Today we're going to talk about partitioning hard drives and some miscellaneous setup issues that can occur or you need to be aware of. And with that, let's go ahead and begin this session. So we begin by talking about partitioning hard drives. Now, a hard drive partition is also known as a volume. A hard drive volume is what is given the drive letter. So the C drive, the main drive, is a volume and it is a partition. Keep that in mind. Partitioning involves the logical division of a hard drive or drives into designated spaces. A physical hard drive can contain more than one partition. A partition can span more than one physical hard drive. A hard drive partition is either primary or extended. A hard drive can contain up to 4 partitions. Only one of those partitions can be extended. One of the primary partitions is marked as active. That's where the system boots. Now, an extended partition is used to get around the 4 partition limit. It acts as a container to hold logical drives. It's not very common anymore, but it was a way to get around the 4 partition limit. Now, I was just talking about partitioning hard drives, and those were MBR, Master Boot Record hard drives. They came out with a newer system that's called GPT, Globally Unique Identifier Partition Tables. Now, this is supported by many newer operating systems, and this allows for disks that are larger than 2 terabytes. It can hold up to 128 primary partitions. But it only works on fixed disks, regular hard drives. It does not work on USB or flash drives. Now, there are 3 basic types of partitions. There's the basic partition. That's where the user establishes it. The user sets the size, and it is the most basic and easiest of partitions. Then there's the dynamic partition. That's where you allow the operating system to decide how much space is needed for that partition, and it can increase and decrease as needs arise and fall. Then there is a logical partition. This is where it spans multiple disks. This is a type of dynamic partition, by the way. Now let's talk about miscellaneous setup issues that may arise or that you need to be aware of. And the first thing we need to talk about is formatting the hard drive. A quick format versus a full format. In a quick format process, the system does not check the hard drive for bad sectors before laying down the file structure. It's faster. Now, the full format does check for bad sectors and marks them so that it doesn't put files in those bad sectors. It's slower, but it's much safer. You need to be aware that when setting up a system, that you may need to have the third-party drivers on hand for any hardware that's installed in the machine. Then there is the type of network setup that you're going to have. It's going to be either workgroup or domain. The workgroup is the most basic. Users will need to have accounts on each machine that they need to have resources shared. Now, a domain is more of a business-oriented method. That's where there's central control of shared resources. A user has one account that grants access to all authorized resources. When you're setting up a PC, remember, you need to know what region you're in, what the time is, the date, what language settings you're going to use. These are required inputs during installation. You can use a script file to answer the question. Then there's Windows Update. It is recommended that you use Windows Update right after the installation. Make sure everything's current. And then it's recommended that you automate updates. You set a time and allow for the process to become automated. The last thing that you need to consider is the OEM recovery partition. Many consumer off-the-shelf systems no longer come with systems disks. It's all contained in the recovery partition. And the recovery partition is used to bring a system back to factory original, including all the default programs that you took the pains to remove in the first place. I do warn that you should use caution when modifying that partition. Now that concludes this session. We talked about partitioning hard drives and some miscellaneous setup issues that you should be aware of or consider. Now, on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on command line for networking. Today we're going to be talking about what command line tools are, and then we're going to discuss some networking command line utilities. And with that, let's go ahead and begin this session. Of course, we get to start by talking about command line tools. Now, command line tools are a utility or a set of utilities that are accessed from the command line interpreter. Usually they are accessed from the desktop, but not always. Now, to access them in Vista, you click on Start, and then in the Run box you type Command or CMD. In Windows XP, you click on the Start button, then you click on Run, and then you can enter CMD or Command to get access to the command line. Now let's talk about some networking command line utilities. The first command we're going to discuss is ping. Ping can check for TCP IP stack initialization if you ping address 127.0.0.1. It's also used to check for basic connectivity between two nodes, which is really useful when diagnosing network issues. It uses ICMP echo requests as kind of a sonar system. It sends a signal out and then waits for the response back and logs it. The basic command format for ping is ping followed by the IP address in dotted decimal format. You can also use the user-friendly name of a node with ping. So that would be like ping www.google.com. Its behavior can be modified in several ways. You can use the / after typing in ping to find out what modifiers are available for ping. Another useful utility for networking is tracert. That's Microsoft's implementation of the traceroute command from Unix Linux. It will trace the route between two nodes as it goes through routers. It also uses ICMP requests. It logs the response from routers and the end node, but it does have limited usability as many routers block ICMP requests. It uses the same basic format as ping, only of course you begin it with traceRT. Its behavior can be modified as well, and you use the / to determine which modifiers are available. Now let's talk about netstat. Netstat is used to list all inbound, outbound TCP IP connections on a given node. It's very useful in determining which connections are consuming network resources. The net command is most commonly used to map a remote shared drive or resource to the current node. An example of that would be if you wanted to map a network share, would be C:\net space use space, then a drive letter, space, and then // and then the path to the shared resource. It has some other great uses, and I recommend that you Google Windows 7 password recovery to find one of the great uses for the net command. NSLOOKUP is used to query DNS to determine if a record exists. It's very useful in troubleshooting DNS issues. Now let's talk about NBTstat. It's used to troubleshoot NetBIOS over TCP IP. It's very similar in function to ARP, only with NetBIOS. NetBIOS is the human-friendly name given to nodes, and we will be discussing ARP in just a moment. I find the ipconfig command to be very useful when I'm troubleshooting networking issues. It lists the IP configuration for a given node. You use it in conjunction with ping and with tracert to determine if there is an IP address conflict. Now let's discuss ARP, Address Resolution Protocol. It's used to resolve IP addresses to MAC addresses. That's how a switch knows where to deliver a packet. Use ARP at the command line to resolve ARP table problems. Now that concludes this session on command line for networking. We discussed command line tools, and then we discussed some networking command line utilities. Now on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do it again soon. I'm Brian Farrell, and welcome to PACE IT's session on command line tools for the operating system, Part 1. Today we're going to talk about what command line tools are, and then we're going to discuss some operating system command line utilities that you can use. And with that, let's go ahead and begin this session. We're going to start with command line tools and what they are. Now, command line tools can be a utility or a set of utilities that are accessed from the command line interpreter, the CLI. Usually it is accessed from the desktop, but not always. When you do have the command line up, you can use / to find out what modifiers can be used with which commands. Now, when you want to access the command line from Windows Vista or Windows 7, you left click on the Start button, and then in the Run box, you type in Command or CMD. That'll get you access to the command line. On Windows XP, you left click on the Start button, then you click on the Run, and then you can type in CMD or Command into the Run box to get access to the command line. Now let's talk about some operating system command line utilities that you can use. We're going to start with directories. And the first command lines that you should know are MD, RD, and CD. MD stands for Make Directory, and it can create a directory in a given location. RD stands for Remove Directory. It deletes a directory if the directory is empty, which means it has no files or folders in it. CD is how you can change directories. It's the navigational commands. Now let's move on to Del. Del stands for Delete. That erases things. Del can delete files and folders, but not directories. Then there's Format. This prepares a hard disk to receive data and installs a file structure, as in FAT32, NTFS, or GPT. Caution. If you use the Format command, it will delete the file structure table, which makes recovering previous data rather interesting. Now let's move on to some copy commands. So of course we begin with copy. It's used to copy a source file or directory to a named destination. Copy didn't have quite the utility that Microsoft was looking for, so they came up with Xcopy. It's a more robust utility than copy. It can use to make an exact duplicate of a source. You can use it to duplicate a program onto a CD-ROM or flash drive. Then Microsoft came up with RoboCopy, which stands for Robust File Copy, and it shipped with Windows Vista and newer. And it is the functional replacement to Xcopy, and it is, again, more robust. Now let's move on to taking care of the hard drive. The first command we're going to talk about is diskpart. It stands for disk partitioning. It's a manual method of partitioning a disk. It's an advanced tool that can manipulate disk space from the command prompt, even when the disk management graphic user interface is not available. Now let's talk about CHK-DSK, check disk. This checks the integrity of the designated disk. It can help recover files in some cases of corruption. A companion command to check disk is FFC. That stands for System File Checker. It's used to check the integrity of systems files on a disk. It can help in cases of a system file corruption that have been caused by a virus infection. Now let's move on to some other commands, and let's talk about task list. It displays a list of all tasks and services that are running on a machine. It also displays memory usage and the process identifier. the PID. Now you should run task list before you run task kill. This is used to end one or more tasks or processes, and it can kill the task using the PID or the image name. Then we have shutdown. Shutdown is a manual method of forcing a shutdown, restart, or log off from the command prompt. And that concludes this session on the command line for the operating system, part 1. We talked about what command line tools are, and then we discussed some operating systems command line utilities. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the command line for operating systems, part 2. Today we're going to be talking specifically about command line to recover from a crash. In order to do that, we need to talk about how to enter recovery mode, and then we're going to talk about some command line utilities that you can use once you are there. And with that, let's go ahead and begin this session. Of course, we're going to begin this session by talking about how to enter the recovery mode, which is where you want to be if your system will not boot up. The first thing that you're going to need are your system's disks. You're going to need the operating system. It needs to be the same disks as the operating system that you're trying to repair. Then you need to insert the media, whether it be USB or CD, and boot to that media. In order to do that, on a lot of systems, when you power up, you can hit F8 to adjust the boot order. Although you might have to enter the BIOS in order to change the boot order. Once it comes up, you'll be given an option to repair. If you pick that option with Windows XP, you'll enter the repair console. If you pick that option with Windows Vista and newer, you'll enter the repair environment. You fix the problem, then you power down, remove the media, and then power the PC back up to ensure that the repair has been made. Now let's talk a little bit more about the recovery console in Windows XP. You use it to help recover a crashed system. Once you bring it up and you have the command prompt, you can always type in /? and then enter to find out the list of commands that are available to you from this command prompt. Now let's talk about the recovery environment. That's in Windows Vista and newer. Just like with the recovery console in Windows XP, this is used to help recover a system that has had a problem. Once you get the command prompt, you can, as with all command prompt utilities, type /? to list the display of the commands that can be used. Now let's discuss the most common recovery console and recovery environment commands that are used to recover a PC that will not boot to the graphical user interface. The most common commands that you're going to use to help recover a system that won't boot for Windows XP are fixboot and fixmbr. Fixboot writes a new boot partition record to the designated hard drive, and this will fix most booting issues. If fixboot doesn't work, you can always try fixmbr. That writes a new master boot record to the hard drive. You need to use this with caution because it can damage the partition table. The process is almost the same in Windows Vista and newer operating systems. The main difference is that you need to begin the command with bootrec. Bootrec stands for boot reconstruction, and you must use it before you use fixboot and fixmbr. As a matter of fact, those two commands are not available until after bootrec has been entered. Fixboot and fixmbr work the same in Windows Vista and newer operating systems as it did in Windows XP. Now that concludes this session on command line for the operating system, part 2. We discussed how to enter the recovery mode when your system is crashed. And then we talked about some command line utilities that you can use to recover once you're there. Now on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Administrative Features and Tools, Part 1. Today we're going to discuss quite a few administrative tools and features, and there's a lot here, so let's go ahead and begin this session. We're going to begin by talking about the Computer Management Console. The console has a lot of useful features in it, and it's used to assist in the administrative function of a computer. The console is available through the control panel and the administrative tools icon. Then you select Computer Management to open up the console. Once you're there, you have access to system tools, storage tools, and service and application tools. Now let's talk about the device manager. There are different methods to gain access to it. From the Start menu, you can right-click on the computer and then select Properties and select Device Manager. Or you could right-click on Computer and select Manage. From the control panel, you can select System and then select Device Manager. From a run box or search box, you could type in Device Manager. Or from the Computer Management Console under the heading of System Tools, that also will get you to Device Manager. Now the Device Manager allows the administrator to quickly determine the status of hardware and firmware. The administrator can update hardware drivers from here really easily. And it can also help to resolve mysterious hardware issues. If you have a piece of hardware that's not operating as expected, check the Device Manager. Now let's discuss users and groups. Users are the profiles of people who are allowed to utilize the system. These profiles are used for authentication. That's proof of who the person is through the use of usernames and passwords. It can also be used for authorization, what that person is allowed to do, in non-domain situations. Now, users can be placed into groups, and a user must belong to at least one group. Now let's talk about groups. Groups use the concept of least privilege. And what that means is that groups are only assigned privileges based on what is necessary to get the job done. No extra privileges are granted. Groups are assigned those privileges by the administrator. Now, Windows does come with many different default groups that can be modified, or you can create your own groups. Now, in order for the users and groups function to be available, the operating system must have the ability to join domains. Now let's move on to security policy, performance monitor, and services. We'll begin with local security policy. This gives you granular control of security privileges. The applet includes many settings that are used to secure the local computer. Some settings are only available from this applet, and it is available through the control panel or through secpol.msc. Now let's discuss Performance Monitor. It quickly evaluates overall system performance. The user can establish which parameters to monitor, and it can be viewed in real time, or reports can be logged, which can then be viewed in Event Viewer. Now let's talk about services. PCs utilize services constantly. From this panel, or this applet, users can modify the operation and behavior of services. You can shut them down, you can start them, so on and so forth. Now let's talk about Task Scheduler. This allows the user to schedule tasks to occur when certain conditions are met. There are many different triggers that can be used to schedule a task, and once that criteria is met, the task happens. Component services allow the user to make adjustments to COM objects. It's available in Windows XP and 7 from administrative tools, but if you're using Vista, then you need to add it as a snap-in into the Microsoft Management Console. Data sources connect an application to a database. As a rule, if an application needs to connect to a database, it does so automatically, but not all applications are created equally and need some assistance. That occurs from here. The Print Management applet is used to manage and control the behavior of printers and their drivers. It's often a great applet to use to manage networked printers. Do you suspect that your PC has a memory problem, a RAM problem? Well, RAM doesn't go bad often, but when it does, it can be difficult to diagnose. That is where Windows Memory Diagnostic comes into play. This tool is used to diagnose the issue, and the report can be seen in the event viewer. Windows Firewall is a powerful personal firewall that's built into all Windows operating systems from Windows XP and newer. The object of the firewall is to control traffic into and out of a PC in an attempt to prevent malicious code from running. Now, from Windows Vista onward, there was Windows Firewall with advanced security. The firewall is made more powerful and allows for more granular control of the firewall. Now that concludes this session on administrative features and tools. Your brain's probably pretty full, so we should conclude it here. On behalf of PACE IT, thank you for attending, and I'm sure we will do some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Administrative Tools and Features, Part 2. Today we're going to be talking about System Configuration and Task Manager. And with that, let's go ahead and begin this session. We're going to begin by talking about the System Configuration tool. The System Configuration tool is also known as msconfig.exe. It's a very powerful tool that allows the administrator to control the behavior of a PC. Now, how do you access the system configuration? Well, it's located under the Administrative Tools icon in the Control panel. Or you can type in msconfig.exe from a run or search box to get access. Once there, you're presented with 5 different tabs: General, Boot, Services, Startups, and Tools. Now let's discuss each of those tabs. Now the General tab is a representation of a batch file that instructs the PC on what to do and what to load upon a boot request, upon power up. From the Boot tab, the administrator can tell the PC where to boot from on the next power up and how the boot will occur. Will it be a safe boot? So on and so forth. It's particularly useful on dual boot systems. The Services tab shows what services are available to the PC right now. It involves a snapshot in time. It shows the status of the service as well. Not all services are listed there, but they all can be accessed from the Services applet, which will provide more use. From the Startup tab, the administrator can control what is loaded automatically upon boot. It's also a representation of a batch file that tells the PC what applications and services to load. If you modify anything under this tab, a reboot is necessary in order for it to take effect. The Tool tab can be used as quick links to tools that are available to the administrator. They can also be accessed by other methods. As a bonus, let's talk about some caution that should be used when modifying the Startup tab in Windows XP. If you cause certain files not to load upon boot, you may find that your system doesn't boot. So you should do some research and use care and caution when modifying the Startup tab in Windows XP. Now let's talk about the Task Manager. The Task Manager is a very useful system tool, and it provides a wealth of information and allows for instantaneous control over the system. So how do you access it? My favorite is Control-Alt-Delete. You can also use Control-Shift-Escape. Or you can right-click on the Windows taskbar and select the Task Manager option. Now, Task Manager has evolved over the years, and each operating system is slightly different, but they all function approximately the same. The screenshots in this presentation will be from a Windows 7 machine, so yours may be different. So now let's talk about the Applications tab. That shows all the current active, or not so active, programs. The In Task button will force close a highlighted program, which is especially useful if the program is hung or not responding. The Processes tab shows what processes are currently running on a Windows PC. It's very useful in determining which processes are overutilizing the CPU or consuming too much RAM. The Services tab does the same thing for services. As such, it is very similar to the Process tab. Time for more bonus material. What's the difference between a service and a process? Well, a service runs in the background with no user interaction. It's often called a daemon. A process is an instance of an executable program. The Performance tabs shows the administrator a visual reference of current system performance. You can evaluate CPU and RAM utilization from here, and it does grant access to the resource monitor, except in Windows XP. The Networking tab gives the user a visual of how much of the system's available network bandwidth is being utilized. Now let's talk about the Users tab. It displays all the users that are currently logged into a PC. There's usually only one, but Windows Workgroup does allow for up to 10 concurrent connections to a PC. So you could see more than one there. You could also see more users there if you're utilizing fast user switching or remote desktop. It allows you to see which users are currently active on a given node at any time. Now that concludes this session on Administrative Tools and Features, Part 2. We talked about system configuration and the task manager. Now on behalf of PACE IT, thank you for watching, and I'm sure we'll do some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Administrative Tools and Features, Part 3. Today we're going to be talking about disk management. We will also discuss some utilities that are available through the command line, and then we're going to talk about some transfer tools. And with that, let's go ahead and begin this session. We're going to begin by discussing the disk management tool. Now, the disk management tool is available in all current versions of Microsoft's operating system. It provides a graphical user interface for managing drives on a system. It allows the user to determine the drive status, to mount drives, to extend partitions, split partitions, assign drive letters, add drives, and add arrays. In other words, it allows you to manage the disks. Now let's talk about drive status. There are several different statuses that could be there. If the status is healthy, that's great. That's what you want to see. If the status is unreadable, guess what? That indicates a failure. That's not good. If it's foreign, that means that there is a dynamic disk that has been moved from one system to another. If the status is online, that means you're ready to go. If it's online error, that's an indication that the drive is about to fail. I'd recommend doing something about that. If the status is offline, that means that the drive is currently not available to the system, and it could indicate a hardware failure. A status of missing means that the system knows about the hard drive but can't find it. The last status, failed, is pretty self-explanatory. So what does mounting a drive mean? For those of you who are familiar with Unix or Linux, no point in discussing it. For those of you who aren't, well, it creates a logical pointer to a drive instead of assigning a drive letter. And it can be used in place of spanning a volume. Extending partitions, that's reclaiming unallocated space on a drive. Splitting partitions, well, that's just what it sounds like. It's taking one partition and making it into more than one partition. Microsoft operating systems automatically assign drive letters to new volumes. Disk management allows the user to assign a desired drive letter to the volume instead. The disk management tool makes adding a drive easy for the user through the graphical user interface. The disk management tool also makes adding an array easy. This is Microsoft's method of implementing a software-based RAID. Now let's talk about some utilities that are available through the command line. Now we're not going to be talking about the command line per se, but I should throw this statement out there, that you need to know the command line and what you can access through it. Now to get access to the command line, you can use Command or CMD from a run or search box to get there. Now here are some of the utilities that are available from the command line. There's msconfig, also known as system configuration. It's a configuration utility. Then there's regedit. That's a utility that is used to edit the system registry. I do recommend care and caution when utilizing regedit, as it's easy to make mistakes. Then there's services.msc. That will bring up the services utility. If you enter MMC, that will start up the Microsoft Management Console. Typing in MSTSC will engage the Microsoft Terminal Services Client. That's for remote desktop. Entering Notepad brings up, guess what? Notepad. It's a great simple text editor. If you want to engage Windows Explorer, you can type in Explorer from the command prompt. Typing in msinfo32 will bring up the System Information utility. Typing in dxdiag will bring up the DirectX diagnostic tool. Now those are just some of the utilities that are available from the command prompt. Now let's talk about transfer tools. Why are transfer tools necessary? Well, PCs do become obsolete, and sometimes you want to transfer settings and files between computers. Microsoft does understand the pain, kind of, that is caused when transitioning from an old PC to a new one. And so they came up with some tools to help ease that pain. They originally came up with Files and Settings Transfer Wizard. That was in XP. It's a basic wizard that is used to transfer user settings and files. Because of user input, Microsoft came up with Windows Easy Transfer for Vista and newer operating systems. It's a replacement for the Files and Settings Transfer Wizard. And it supports several different methods of transfer. Portable hard drives, USB flash drives, direct connection, so on and so forth. But it is still fairly basic. For the advanced user, there's the User State Migration tool. This allows advanced users to use script to customize the transfer of files and settings between computers. And it's currently only available as a command line utility. Now that concludes this session on Administrative Tools and Features, Part 3. We covered the Disk Management tool. We discussed some utilities that are available from the command line, and we ended it on transfer tools. Now on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do some more soon. Hello, I'm Brian Farrell, and welcome to PACE IT session on Control Panel Utilities, Part 1. Today we're going to discuss what the control panel is, and then we're going to discuss the Internet Options applet that is available from the control panel. And with that, let's go ahead and begin this session. So let's start by discussing what the control panel is. It's a user interface that gives access to applets, small programs, that the user can use to adjust basic system settings. It can be a very handy tool with a knowledgeable tech. Have some problems that you need to get rid of? Look in the control panel and you'll probably find an answer. And with that, let's move on to the Internet Options applet. So what is the Internet Options applet? Well, it's used to control the default behavior of Internet Explorer. Once you open it, you'll find that there are 7 tabs. So let's go through those tabs. We're going to start with the General tab. It sets the general behavior of Internet Explorer. From here, you can set the home page, or you can see what home page has been set. From the startup setting, you get to decide where Internet Explorer begins, either from the home page or from the last session. The Tabs section allows the user to modify some behavior of how tab pages and pop-ups behave. The section on browsing history allows some control over cookies and history. You can set it so that Internet Explorer deletes the browsing history when it closes, or you can manually delete the caches from here. From the Appearance section, some modifications can be made to how web pages appear. Some versions of the Internet Options applet do have a section where you can set the default search engine. This version did not have that. Now let's look at the Security tab. From here, you can reduce your risk through the use of zones. In the zones, you'll find different settings. There is Internet, which is the default for Internet web pages. Then there's Local Internet. That's the default setting for an intranet, or local network. Then there are Trusted Sites. Those are user-identified sites that can be granted more privileges than Internet sites. It's a more relaxed security. Then there are Restricted Sites. These are user-identified sites that have more restrictions placed on them. They can still be visited, but what the web pages are allowed to do is greatly reduced. You can set custom levels for each zone. Internet Explorer allows the user to modify all of the default behavior. Caution should be used. Make sure you understand the ramifications before changing the default setting. Now let's move on to Privacy. The Privacy tab allows some control over online privacy. The Settings section allows some control over how Internet Explorer handles cookies. The settings range from accept all cookies to block all cookies with various options in between. The Location section either allows or disallows a website from determining your physical location through your IP address. The pop-up blocker can either be on or off. If the pop-up blocker is turned on, the settings under this heading allow the user to manage which sites are allowed to use pop-ups. The In Private section. By default, when the user engages the Internet Explorer in Private browser function, Internet Explorer disables the toolbars and extensions. This can be changed from here. Now let's move on to the Content tab. This tab is used to control what content is displayed and what data is kept. The Family Safety section, also known as Parental Control, is used to place restrictions on Internet usage for specific user accounts. Some versions of this utility have Content Advisor. This is used to place restrictions on what content is viewable in Internet Explorer. An administrator can enter a code to bypass this setting. The Certificates section is used to manage how and which security certificates Internet Explorer will accept. Internet Explorer can remember information used to fill out web forms and uses the autocomplete function to autocomplete forms for the user. The behavior for this can be adjusted from here. The Feeds and Web Slices section is used to adjust how Internet Explorer controls and schedules RSS and web slices. Now let's move on to the Connections tab. This controls how PCs connect to networks, and there are several different sections under this tab. The Setup button starts a wizard that will help to establish an Internet connection. Under the Dial-Up and Virtual Private Network setting, you can add a dial-up connection or a VPN from here. The Local Area LAN Settings button can control how a PC connects to the LAN, and the use of a proxy server can be enabled from the LANs setting button. Now let's discuss the Programs tab. This sets how Internet Explorer handles certain situations and extensions. Now, most applications use the proper defaults, but in certain situations, they may need to be reset to a user's preference. The Manage Add-ons section allows the user to modify how extensions operate in Internet Explorer. If you wish to view the coding for a web page or to edit a web page, the HTML default editor can be set from this section. The last tab is the Advanced tab. This allows for advanced control over Internet Explorer options. You need to be sure of the ramifications before changing defaults here. Internet Explorer security can be greatly reduced or enhanced by making adjustments here. Now that concludes this session on Control Panel Utilities. We briefly discussed what the Control Panel is, and then we went into a fairly in-depth discussion on the Internet Options applet that's available in the Control Panel. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we will do it again soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Control Panel Utilities Part 2. Today we're going to discuss some of the Control Panel utilities that are available in all versions of Windows. And with that, let's go ahead and begin this session. We're going to begin with the Display Settings applet. This utility can control different display settings that the user may adjust. You can adjust resolution, calibrate color, change display settings, adjust clear text type. Those are just some of the settings that you can change. You do need to use caution if you're using a flat panel display. They do have a native resolution. If you change the resolution, you may have a distorted image. The User Accounts utility is used to manage or add users to a PC. You can also manage your credentials. You can manage file encryption certificates from here. You can configure advanced user profiles and properties or change the environmental variables for the system. The Folders option utility is of special importance to a technician, and I will get to that here in just a moment. But from here, you can manage the default behavior of folders or files. There are 3 tabs: General, View, and Search. From the Generals tab, you can make adjustments to the basic behavior of files and folders. From the View tab, you can establish how files and folders are represented. The user can unhide protected files and folders from here. That's the important one for a technician. The Search tab establishes how the operating system searches folders. The Systems utility is another important one for the technician. From this utility, information about the system is available, like the operating system that's used, the processor, and the amount of RAM. It also gives access to additional applets or utilities, like Performance. That's an extension of the Task Manager and gives a more detailed view of system performance. From the Remote Settings utility, that's where you can set the options for remote access to the system. The Systems Protection utility allows for system restore. Now let's briefly discuss Windows Firewall. It is a utility for system protection. It's a software-based firewall that protects against malicious code. It controls traffic into and out of a PC. Windows Firewall should be active unless another firewall product is present and active. Now let's discuss the Power Options utility. This applet is used to adjust power usage. The user or administrator can set the power profiles for any given situation. There are several different preset power plans. These set the PC's power usage profile for a given power scenario. Now let's discuss several of the behaviors that you can adjust. We will begin with Hibernate. This sets the PC's behavior when idle for a specified amount of time. It saves more power than the sleep mode, as the contents of RAM is placed onto the disk drive. Then there's Sleep Mode, also called Suspend or Standby. This sets the PC's behavior when it's been idle for a specified amount of time. It has faster recovery than Hibernate, as trickle power is kept to the RAM and the contents of RAM are preserved. Now that concludes this session on Control Panel Utilities. We briefly discussed the Display Settings utility, the User Accounts applet, the Folders option applet, the Systems utility, Windows Firewall, and the Power Options utility. Now, on behalf of PACE IT, thank you for watching this session, and we will do it again soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the Control Panel Utilities Part 3. Today we're going to be discussing utilities that are unique to Windows XP, unique to Windows Vista, and unique to Windows 7. And with that, let's go ahead and begin this session. So we're going to begin by talking about utilities that are unique to Windows XP. We will briefly touch on each of these utilities that are unique to Windows XP. And the first one is the Add Remove Programs utility. This is the best-in utility for removing programs from Windows XP. You can also add operating system features with this utility. The Networks Connection utility is used to modify how network interface cards behave and network connections. The Printers and Faxes utility is used to add or modify printers and their drivers. Then there's the Automatic Updates utility. This is used to modify the behavior of automatic updates. The final utility that we will discuss that's unique to Windows XP is the Network Setup Wizard. This walks the user through the steps to set up a small office, home office network. Now let's move on to utilities that are unique to Windows Vista. The first utility that we will discuss is the Tablet's PC Settings utility. This is used for tablets, and handwriting recognition can be set here. The Pen and Input Devices utility is used to set stylus and other input device behavior for touch-enabled devices. The Windows Vista operating system added offline files capability, and the offline files utility is used to enable a hosted file to be kept locally. It also establishes the synchronization behavior for when it goes back online. The Problem Reports and Solutions utility checks for solutions to known PC problems and sends reports to Microsoft. Instead of printers and faxes, Windows Vista has a Printers utility that has the same functionality as the Printers and Faxes utility in Windows XP. Now let's discuss utilities that are unique to Windows 7. The first utility that we need to discuss that's unique in Windows 7 is Home Groups. It's a simpler method for sharing printers, files, photos, etc. It's only available in Windows 7 and newer operating systems. Windows 7 introduced the Action Center utility. This is used to monitor key security settings. It also includes additional alerts that the user may want to investigate. The Security Center that's available in XP and Vista are their versions of the Action Center. The Remote Applications and Desktop Connections utility establishes and manages quick links to remote applications or desktops. And finally, there's the Troubleshooting utility. This contains several other applets that can be used to troubleshoot PC problems. Now that concludes this session on Control Panel Utilities Part 3. We briefly discussed Control Panel utilities that are unique to Windows XP, unique to Windows Vista, and unique to Windows 7. Now on behalf of PACE IT, thank you for watching this session, and I'm looking forward to doing more. Hello, I'm Brian Farrell, and welcome to PACE IT session on Client-Side Networking Setup, Part 1. Today we're going to discuss home groups, some of the differences between a work group and domain network setup, and then we will discuss network shares and mapping drives. And with that, let's go ahead and begin this session. So of course we begin by discussing home groups. Home groups were introduced with Windows 7. You can think of home groups as a form of ad hoc networking. Microsoft calls it the easiest method of sharing resources on a small network. All versions of Windows 7 and newer can join home groups, but only Home Premium and higher versions can create them. So how do you create a home group? Well, first off, you go to the control panel and you select the home group's utility. Once there, you click on the Create a Home Group button. Then you get to select which resources you want to share with the home group. Windows will share the corresponding library of resources. Then you click Next. Now the home group is created and a password is displayed. You need to write down the password because you may need it later. Then you click Finish. Then you share the password with those that you want to join your home group. So once a home group is created, how do you get other PCs to join it? Well, you select the home group utility from the control panel. If a home group has already been created, you will get a prompt to join it. Then you determine what you want to share with the home group. Then you enter the proper password for the home group. Remember I told you to write it down earlier? Home groups are now set up. Now let's discuss some of the differences between a workgroup and domain network setup. We begin with workgroups. Workgroups are easy and simple. You can think of them as peer-to-peer networking. They do work best for small networks, 10 or fewer user machines. Why is that? Well, because if you're going to share resources on the network, then your machine needs to have a user account for each person that needs access to that resource. That's because workgroups use a separate account database on each machine that's involved in the network. Now, domain networks are slightly more complex, but they're also more secure and easy to manage. That's because the user has one account that is used to authenticate and authorize access to needed resources on the network. Domains use a central account database to handle user resource requests. And if you've already put a file server on your network, then you might as well go ahead and set up a domain network, since you're almost all the way there already. Now let's discuss how you join a workgroup or a domain. The steps that are required are very similar with just a few changes. You begin by clicking the Start button, and then right-click on Computer and select Properties. Once you're on the Properties page, select the Advanced Systems setting, then click on the Computer Name button, then click Change. From here, you can join a workgroup or a domain. If you join a workgroup, all you need to do is change the workgroup name. A reboot is required in order for you to finalize the step. You can also join a domain from the Change Name screen. You click on the proper button and then you enter the name of the domain you wish to join. Then you enter the proper username and password. This also requires a reboot in order for that PC to join a domain. Now let's talk about network shares and mapping drives. A network share is any shared resource on the network. It can be as simple as a file or folder. It can be space on a disk drive or even a whole disk drive itself. Now, access to network shares is gained by using the Universal Naming Convention, UNC, from a runbox. The standard format is // computer name / share name. It is easier, though, if you're going to connect to that network share on a regular basis, to use drive mapping. Now, mapping a drive simplifies the process of connecting two network shares. So how do you map a drive to a network share in Windows 7? Well, you click on the Start button, then you select Computer, and then you click on Tools. From that drop-down, you select Map Network Drive. Then you select the drive letter that you want that network share to have. Then you enter the Universal Naming Convention, the // computer name / share name, and then you select Reconnect at Logon and then Finish. From now on, you will have a shortcut link to that network share available from the desktop. Now that concludes this session on client-side network setup. Part 1. We discussed home groups. We discussed some of the differences between workgroup and a domain network setup. And we finished by talking about network shares and mapping drives. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do some more soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Client-Side Network Setup, Part 2. Today we're going to be discussing how to establish various network connections, proxy settings, and then we'll finish with remote desktop. And with that, let's go ahead and begin this session. So let's begin by discussing how to establish various types of network connections. The first network connection we're going to discuss is the dial-up connection, old school. Now, dial-up requires a modem and an internet service provider that will accept a dial-up connection. How do you set one up? Select Network and Sharing Center from the control panel. Select Set up a new connection or network, and then enter the information provided by the ISP. That's the phone number to use, your username, password, etc. Then you get to choose to either allow or disallow other people to use your network connection. And then you get to select Create, and you're done. Now let's discuss VPN. VPN is a virtual private network. This allows for a private connection over a public network. It creates an encrypted tunnel between the PC and the VPN server or firewall. How do you set one up? Select Network and Sharing Center from the control panel. Select Set up a new connection or network. Select Connect to a workplace. Select Use my internet connection, VPN. Enter the IP address of the VPN server. Then you need to enter the proper username and password, and a domain if required. Select Connect. The computer will cycle through all of its available tunneling protocols until it and the VPN server agree upon which one to use. And then you have your connection. Now let's discuss wireless network connections. Now, wireless networks require the capability, so you need to have a wireless adapter at the minimum for your PC, and a compatible wireless access point, a WAP. And if you really want to add functionality, you need an internet connection. So how do you set one up? The first thing is you need to know your service set identifier, your SSID. That is the wireless network's name. Then you should know the type of security used. Is it WEP? Man, I sure hope not. How about WPA? Again, a fail. It should be at least WPA2 or 802.x. But you still need to know which security protocols are in play. Then you click Start. Then you select Connect to from the Start menu. Select the wireless network you wish to join. Then you select Connect. Then you enter the proper credentials at the prompt and select OK. Now you're connected to a wireless network. Now, a wired connection requires a network interface card, a NIC. Actually, they all do. You also need the proper type of cabling, Cat5, Cat5e, is it Cat6, etc. You also need a way to connect to the network, which would be a hub at the minimum. It would be preferred that you use a switch or a router, or both. Now let's discuss setup. In most cases, the setup for a wired network is fairly automatic, as access to a functioning switch port is deemed sufficient authorization to use the network. Setup of both wired and wireless networks often use DHCP, Dynamic Host Configuration Protocol, to configure the proper IP addresses. Let's move on to proxy settings. Before we can discuss the proxy settings, we need to discuss proxy servers. These enable a network to use caching and filtering on the network. Well, caching conserves bandwidth because it saves frequently requested web pages in its cache. and it provides filtering because it will restrict access to web pages. An added benefit to using a proxy server is that the end user is hidden, shielded from the internet. They're never seen. Only the proxy server is seen. With that taken care of, let's discuss proxy settings. Most client-side proxy settings are established by the browser. So how do you set one up? Select Internet Options from the control panel. Click the Connections tab, and then go down to the LAN Settings button. Check the box that says Use a proxy server for your LAN. Enter the IP address and the port for the proxy server. It is possible to bypass a proxy server for the local network traffic. And then you click OK, and you've established your proxy settings. Now let's move on to remote desktop. Now, allowing remote desktop access means that you can access your PC from almost anywhere that you have an internet connection. Remote desktop can be a powerful tool in your arsenal, but it also creates a vulnerability in your network. Now, remote desktop settings need to be allowed before the remote desktop can be enabled. By default, Windows Firewall blocks access to the remote desktop feature. So how do you set it up? Well, first off, you go to System from the control panel, then you select Remote Settings. Select the radio button that sets the remote connection level that is desired, and then you click Apply. Then you go to Windows Firewall from the control panel. Select Allow a program or feature through Windows Firewall. Check the box for remote desktop, and then check the box for the type of network profile that you're allowing. Is it private or public? That one's not recommended. And then click OK. You have now created access to your remote desktop. Now that concludes this session on client-side network setup, part 2. We discussed how to establish various types of network connections. We discussed how you establish proxy settings so you can use a proxy server, and we finished with remote desktop. Now, on behalf of PACE IT, thank you for viewing this, and I'm sure we'll do some more soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Maintenance Procedure Best Practices. Today we're going to be talking about what best practices are, and then some maintenance procedure best practices. And with that, let's go ahead and begin this session. So what are best practices? Best practices are a technique or methodology that consistently result in superior results over another technique or methodology. Now, best practices can be standardized across an industry, a single company, or just to an individual. Now, best practices can be determined by policy, company policy. It can be determined by the complexity of the system, or by usage patterns, network constraints, or access to other resources. All of those can have an effect on your best practices. Now let's move on to some maintenance procedure best practices. Backups should be scheduled and verified for integrity. A policy should be in place for how long backups are kept and what kind of backups are maintained. Check disk. As hard disks age, problems can occur with the integrity of the physical surface. Regularly scheduled check disk scans can find and sometimes repair these problems before they become an issue to the user. You should run regularly scheduled check disk scans. Defragmentation. This can reduce the seek times and improve overall system performance. You should schedule defragmentation for spinning disk hard drives on a regular basis to ensure optimum performance. Windows Update. You should use Microsoft's Windows Update to keep the system running well. An update to an operating system can reduce the opportunity for exploitation, and you do have the option for when Windows updates occur and how they occur. You should develop a policy for how you're going to handle them. Best practices for driver or firmware updates are, unless you need the added functionality that they can impart, or unless there is a problem with a driver or firmware, I wouldn't do them. That should be your best practice. Best practices as far as antivirus is that it should be always up to date. New threats are being developed on a regular basis, and therefore for antivirus to be effective, it needs to be up to date constantly. Now let's talk about maintenance procedure best practices for patches. A patch is an update to an operating system or application. Patches are used to fix problems or reduce security threats. You should have patch management best practices in place. And part of your patch management best practices should be that all systems and applications are as up to date as possible. Now, patches can fix problems, but they can also create problems. So whenever possible, test a patch before deploying it in a production setting. And before you deploy a patch, you should make a backup of the system in case of problems. And once the patch has been deployed, thoroughly and systematically test the machine before you call it done. Now that concludes this session on preventative maintenance best practices. We discussed what best practices are, and then we briefly discussed some maintenance procedure best practices. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we will do some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on preventative maintenance tools for the Windows operating system. Today we're going to be talking about some vital maintenance tools that you need to be aware of and what they do. And with that, let's go ahead and begin this session. We're going to begin by talking about backup. Now, the Windows Backup utility provides security in case of disk failure. It can back up your operating system and your hard drives. Now, for Windows XP, the way that you get to the backup function is you click Start, then All Programs, then Accessories, then System Tools, then Backup. And you follow the directions in the wizard from there. The wizard does make it easy to select which files that you want to back up. Your backups can be local or made to removable media. Now, Windows Vista and Windows 7 changed things up a little bit. Vista introduced the Backup and Restore Center, which gives you more options on how backups can be made and where backups can reside. And it is available from the control panel. Now let's discuss the System Restore utility. So there are many things that can affect the stability of a PC. Loading new application, drivers, and updates are just a few things that can affect the stability. Now, System Restore will return a PC to an earlier state, hopefully one that's stable. If you want to get there in Windows XP, you click Start, All Programs, Accessories, System Tool, System Restore, and that'll get you to the available restore points. Now, Windows will create an automatic restore point every 7 days and before certain events take place. You can also manually create them as well. In Windows Vista and 7, the System Restore utility is available from the control panel. Once you get to the control panel, click on System, then System Protection, and then System Restore. Now let's discuss check disk. Hard drives can develop physical errors over time. The Windows operating system may automatically detect these problems and automatically schedule a check disk for that drive on the next reboot. Check disk can mark bad drive sectors and can attempt to recover data from those bad sectors. Check disk can also try to recover some system's files. You can run check disk manually. From Windows Explorer, right-click on the disk or volume that you want to run the check disk. Select Properties, select Tools, select Error Checking, and then select the desired option to either automatically fix file system errors and/or to scan and attempt to recover bad sectors. Now let's move on to defrag. Drives can become fragmented without intervention. Fragmented disks are much less efficient than ones that are defragmented. It is wise and a best practice to run defrag on spinning disks on a regular basis. In Windows XP, defrag is available from within Computer Management, and it has to be run manually. Starting with Windows Vista and on to Windows 7, defrag can be scheduled to run automatically. Typing defrag into a search box will bring up the GUI, the graphic user interface, so that you can schedule the defragmentation process on a regular basis. Now let's talk about recovery images. So a recovery image contains an image of the operating system. It can contain images of all of the installed applications and all of the user's data. The ability to easily create a recovery image was introduced in Windows Vista with the complete PC backup and restore utility, and it's available from the Backup and Recovery Center. Windows 7 changed things just a little bit. The utility is now called Create a System Image and is available from the Backup and Restore applet. Now a word on recovery partitions. A recovery partition is an image, and it's installed by the original equipment manufacturer. If you end up using the recovery partition, you should be aware that user data and installed applications will be lost, but the system will be returned to the factory original condition. Now that concludes this session on preventative maintenance tools for the Windows operating system, and we did discuss quite a few of those preventative maintenance tools. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Basic Operating System Security Settings, Part 1. Today we're going to be talking about users and groups, and then we will discuss NTFS versus share permissions. And with that, let's go ahead and begin this session. We begin by talking about users and groups. Now, Microsoft uses users and group settings as the primary form of authentication and authorization. The user is authorized to perform tasks and functions based on the permissions that are granted through the users and group settings. Individual users can be granted permissions, but it is much more common to place users into groups and then grant the group permission. It's a whole lot easier to manage that way than to manage each individual user. So now let's talk about some of those groups. And we're going to begin with the administrator group. Administrator accounts have complete control over the local machine. The administrator has all rights and permissions on a PC. It's not recommended that this account be used for daily activity. Some groups could be called power user groups. They have near administrator-like powers. The power user can add devices and some drivers and change system settings. About the only thing that a power user can't do is install applications. Now let's talk about the standard user. This is your day-to-day account. This user can run most applications and can modify some system settings, but that's about it. The most restricted account is the guest account, and it should only be created on a temporary basis. The user can run just very basic applications, which do include a web browser. This account should be disabled after it is used. Now let's move on to NTFS and share permissions. NTFS permissions are only available on NTFS drives. Imagine that. Permissions can be based on user or group accounts or both. Now the permissions are either to allow an action or to deny it. And a deny will override an allow every time. Now those permissions are read, the file can be viewed but not modified. Write, the file can be viewed and changes may be saved to the file, but it can't be deleted. Read and execute. Programs require this permission to run. There's modify. The file can be read, it can be written to, and it can be deleted. And then there's full control. The user can take ownership of the file or program. Now, share permissions are a little bit different. Share permissions involve network shares. There are three basic permissions on network shares. There's read. That's the default that every share receives, otherwise you wouldn't have shared it. Change. The user can read and modify the file. And then there's full control, which is the same as in NTFS. NTFS and share permissions do combine. They're cumulative in nature. What happens is the least restrictive permission from NTFS is compared to the least restrictive permission from the share. These two are then looked at and evaluated, and the most restrictive of the two is the active permission. Now let's talk about what happens to permissions when you move a file or when you copy it. Now, when you move a file, you're just changing the location of a file or folder on the local volume, and that has no effect on the permissions associated with that file. When you copy a file or folder, you're actually changing its location to a new volume. Now, when that happens, the permissions are now tied to the target system, the new volume. So whatever permissions are in effect on that volume get applied to the files and folders. Now we need to discuss file and folder attributes. These are very low level and basic characteristics of the file or folder. They kind of work with permissions but are also separate from them. File attributes always take precedence over permissions, whether they are NTFS or share, and file attributes apply to all users. An example of a file attribute is read-only. The operating system will prevent anyone from making changes to the file or folder. The attribute would need to be changed before modifications were possible to that file or folder. Now that concludes this session on basic operating system security settings. We covered users and groups, and then we looked at NTFS and share permissions. Now on behalf of PACE IT, thank you for viewing this session, and I'm sure we will do some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Basic Operating System Security Settings, Part 2. Today we're going to be talking about shared files and folders, system files and folders, and then user authentication. And with that, let's go ahead and begin this session. Let's begin by talking about shared files and folders. When we start talking about shared files and folders, the first thing we need to be made aware of is that there are administrative shares and there are local shares. Administrative shares are a set of default hidden shares that are only available to administrators. These shares cannot be deleted, but they can be disabled, which is the default in the modern operating system. An administrative share can be identified by the $ in its name. As a rule, these shares create access to the most important or vulnerable resources on a system, like the volume's root or operating system files. Local shares, on the other hand, are shares that are created and can be made available to anyone. Now let's discuss folder and file relationships. The folder and file structure involves a parent-to-child relationship. The folder that holds a file is the parent folder. The file that is held is the child of the parent. Two files that are within the same folder are siblings. And folders can also have a parent folder and be a child of that folder. Now, permissions that are granted to the parent folder are by default inherited by the children. The children's permission can be modified, but it has to be explicitly done. You need to use care and caution because it is easy to propagate the wrong permissions by making a change to the parent folder. Now let's talk about system files and folders. System files and folders contain the operating system and other files that are necessary for the system to function correctly. By default, these files and folders are hidden and protected. This default option can be changed by the folder's option applet located in the control panel. Once they are unhidden, an administrator can change the protection level of these system files and folders. That should be done with caution, as changes made to these files and folders can cause security issues or other problems. Now we move on to user authentication. User authentication is proving who you are. Authentication is not authorization, by the way. Once you prove who you are then authorized to perform actions, but you have to prove who you are first. Now, there are three main ways of authentication. The first one is what you know, which is the most common and the one that we're most used to. This is the use of usernames and passwords. You know those. The next method is what you are. That would be biometric authentication. Fingerprint scanners, retinal patterns, voice recognition, so on and so forth. Those are all authentication by what you are. The last method is what you have. That would be like a security token, which uses a rolling code logarithm to supply a secure code. Now, you can combine different forms of authentication. This is called multi-factor authentication, and it's much more secure than single-factor authentication. You may want to consider implementing a single sign-on procedure for your organization. What this does is it uses an authentication server to authenticate users. It allows the user to sign on once to get access to multiple network resources instead of requiring them to sign on for each resource. If you're running a work group, you can't do single sign-on. At the minimum, it can only occur at the domain level. Now that concludes this session on Basic Operating System Security Settings, Part 2. We covered shared files and folders, we covered system files and folders, and we discussed user authentication. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing more. Welcome to PACE IT's session on preventative maintenance tools for the Windows operating system. Today we're going to be talking about some vital maintenance tools that you need to be aware of and what they do. And with that, let's go ahead and begin this session. We're going to begin by talking about backup. Now, the Windows Backup utility provides security in case of disk failure. It can back up your operating system and your hard drives. Now, for Windows XP, the way that you get to the backup function is you click Start, then All Programs, then Accessories, then System Tools, then Backup. And you follow the directions in the wizard from there. The wizard does make it easy to select which files that you want to back up. Your backups can be local or made to removable media. Now, Windows Vista and Windows 7 changed things up a little bit. Vista introduced the Backup and Restore Center, which gives you more options on how backups can be made and where backups can reside. And it is available from the control panel. Now let's discuss the System Restore utility. So there are many things that can affect the stability of a PC. Loading new application drivers and updates are just a few things that can affect the stability. Now, System Restore will return a PC to an earlier state, hopefully one that's stable. If you want to get there in Windows XP, you click Start, All Programs, Accessories, System Tool, System Restore, and that'll get you to the available restore points. Now, Windows will create an automatic restore point every 7 days and before certain events take place. You can also manually create them as well. In Windows Vista and 7, the System Restore utility is available from the control panel. Once you get to the control panel, click on System, then System Protection, and then System Restore. Now let's discuss check disk. Hard drives can develop physical errors over time. The Windows operating system may automatically detect these problems and automatically schedule a check disk for that drive on the next reboot. Check disk can mark bad drive sectors and can attempt to recover data from those bad sectors. Check disk can also try to recover some system's files. You can run check disk manually. From Windows Explorer, right-click on the disk or volume that you want to run the check disk. Select Properties, select Tools, select Error Checking, and then select the desired option to either automatically fix file system errors and/or to scan and attempt to recover bad sectors. Now let's move on to defrag. Drives can become fragmented without intervention. Fragmented disks are much less efficient than ones that are defragmented. It is wise and a best practice to run defrag on spinning disks on a regular basis. In Windows XP, defrag is available from within Computer Management, and it has to be run manually. Starting with Windows Vista and on to Windows 7, defrag can be scheduled to run automatically. Typing defrag into a search box will bring up the GUI, the graphic user interface, so that you can schedule the defragmentation process on a regular basis. Now let's talk about recovery images. So a recovery image contains an image of the operating system. It can contain images of all of the installed applications and all of the user's data. The ability to easily create a recovery image was introduced in Windows Vista with the complete PC Backup and Restore utility, and it's available from the Backup and Recovery Center. Windows 7 changed things just a little bit. The utility is now called Create a System Image and is available from the Backup and Restore applet. Now a word on recovery partitions. A recovery partition is an image, and it's installed by the original equipment manufacturer. If you end up using the recovery partition, you should be aware that user data and installed applications will be lost, but the system will be returned to the factory original condition. Now that concludes this session on preventative maintenance tools for the Windows operating system. And we did discuss quite a few of those preventative maintenance tools. Now on behalf of PACE IT, thank you for watching this session, and I look forward to doing some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the basics of client-side virtualization. Today we're going to be talking about the purpose of virtual machines, the hypervisor, and then conclude with some requirements for virtualization. And with that, let's begin this session. So we begin by talking about the purpose of virtual machine. The main purpose of a virtual machine is to run, guess what? A virtual PC from within a physical PC. The host system sets up and manages the VM. The VM can run almost any operating system, and it can be either sandboxed, which means completely isolated, or it can share in available network resources. Virtual machines are very versatile and are becoming more and more common every day. So why would you need a virtual machine? Well, they're a great way to learn things. You can learn a new operating system inside of a VM without making any changes to your base operating system. This way you can test it out and see if you want to install it on your machine or on a whole host of other machines. Virtual machines can test out application or patches for problems before they are deployed on production machines. In some cases, you may have an application that won't work in a modern operating system. Well, a virtual machine can allow you to load that legacy operating system and the application that requires it in order to run. It's a great way to keep old applications running in the modern era. Now let's discuss the hypervisor. So you may be asking yourself, what is a hypervisor? Well, it's the virtual machine manager. It's the software that runs on top of the host hardware that allows for virtualization. It's what allocates resources to the virtual machine, and it controls the virtual machine's access to other resources, like the network. There are a lot of hypervisors that are out there and available. Some free ones would include Windows Virtual PC. This, by the way, gives you access to Windows XP mode for your legacy applications. The only thing about Virtual PC is it can only run a 32-bit guest operating system. Another one would be VMware Player by VMware. Now this hypervisor can run both 32 and 64-bit guest operating systems. Another free hypervisor is VirtualBox by Oracle. It can also run 32-bit and 64-bit guest operating systems. Now let's move on to some of the requirements for virtualization. Now, besides the need for a hypervisor, you need to be aware that VMs share the physical resources of the host machine. Because of that, the processor and RAM are the keys to a good VM experience. So now let's talk about some of those requirements. For the processor, well, VMs can be processor intensive. So you should try and have a fast multi-core processor, and it does need to be capable of hardware-assisted virtualization. Now, because the VM shares the RAM with the host system, you need to make sure that there is enough RAM present to fulfill the needs for not only the host, but for each VM that's active. A large disk drive can also be a key requirement for a VM experience. As the files grow, you need to make sure that you have space to contain everything, including the VM's operating system. There are also some security requirements for a VM. If you're using a VM to test antivirus, then you need to make sure that it's sandboxed and isolated from the rest of your systems. VMs can share in the network, and because of that, you need to make sure that your NIC, your network interface card, has a high enough throughput to ensure a good network experience for the host and the VM. Or you might consider putting in multiple network interface cards and using one or more of them for your VMs. Now that concludes this session on the basics of client-side virtualization. We talked about the purpose of virtual machines, the hypervisor, and then some of the requirements for virtualization. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do some more soon. Hello, I'm Brian Farrell. and welcome to PACE IT's session on physical security measures. Today we're going to be talking about security at the building level, security at the node level, and finally securing physical documents and passwords. And with that, let's go ahead and begin this session. And the first thing that I'll say is security begins at the front door. Actually, it begins at every door. Locking doors is the first level of security. The level of security that does get deployed should increase as the need increases. So let's talk about which doors need to be locked. Equipment rooms where servers are kept, or server rooms, they should be locked. Network cabinets should be locked, even if they're in the server room. You need to restrict access to only those who need it. Now, you can use electronic locks, and a good thing about those is they do record information, or they are capable of recording information on who opened them and when. If you are in a high security area, you might want to think about installing tailgating prevention measures. Tailgating is when somebody without authorization follows directly behind somebody who is authorized. A turnstile can prevent tailgating. Now, we talked about electronic locks. You might want to consider using electronic locks that are activated by badges. The good thing about using badges, you then know who is who. You can look at a badge and see who has authorization to be in an area if the badge is configured correctly. Now, the badges can have a magnetic strip in them, which can be swiped to unlock doors. Some badges have an RFID chip, radio frequency identifier chip in them, which can also be used to unlock doors. Now let's talk about security at the node level, the PC level. One of the first things that you can implement at the node level for physical security is a privacy filter. Now, this prevents shoulder surfing. What that is somebody looking over somebody else's shoulder to see what's on their screen and possibly get compromised that way. Now, privacy filters will restrict the viewing angle at which a screen can be seen, and it ensures that private things get kept private. Another physical security measure that can happen at the node level also involves badges. If you require badges with a magnetic strip, there are readers that can attach to PCs that require that the badge be inserted before a user can log in. This is especially useful when it also requires a PIN. This now makes it a multi-factor authentication. And talking about that, you can also employ biometric measures. Make people prove who they are, not just by what they know, but by their physical feature. Their fingerprint scanners, retinal patterns, voice patterns, and facial recognition can all be used as a physical security measure. Another security measure that is physical in nature are tokens or key fobs. These can be used both on-site and for remote logins. The token or key fob supplies a security code that changes on a regular basis. It's a rolling code. The changes usually occur about every 60 seconds. When a user is logging in, they look at the key fob and supply the code that's on the screen at that time, along with their username and password. The authentication server knows what the code should be at any given time, and the key fob can be set to each individual to ensure added security. Now let's talk about securing physical documents, as in passwords. You're going, passwords? Well, key admin passwords should be documented in the case of an emergency. You never know, you might get hit by a bus. Now, these need to be secured, and at a minimum, they should be in a locked file cabinet that has limited access. That access should only go to those who have a need to be in it. So what do you do with those documents once you're done with them? Well, you need to prevent dumpster diving. That used to be a good way of gaining access to sensitive information, including networks. You should employ the use of a cross-cut shredder at a minimum, if not an actual document disposing company. Now that concludes this session on physical security measures. We talked about some security measures at the building level, at the node level, and then properly securing physical documentation. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we will do some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on information technology security measures. Today we're going to be talking about the principle of least privilege, user education, and then some digital security methods that you can implement. And with that, let's begin today's session. We're going to begin with the principle of least privilege. Least privilege is an effective security measure. Unless the top-level administration group is compromised, it is easier to contain a breach. People may get annoyed with the policy of least privilege, as they only have the bare minimum of rights and permissions that are required to do their job. But your job as the administrator is to avoid a creep in privilege escalation. Don't make exceptions unless it is absolutely necessary. Now let's move on to user education. You need to help the end user understand security risks. Because of that, you need to train users on what strong passwords are. You should keep them informed about the principle of least privilege. They need to be aware of malware attacks that are out in the wild and that they may be subject to. Help the user to understand how important it is to keep everything up to date, how to resist social engineering attacks, and what other attack vectors are out there. Your training of the end user can be formal and documented, or it can be informal, just swinging by their office or desk and talking with them. Now let's move on to digital security. We begin talking about digital security with a discussion on antivirus. Antivirus software should be installed, active, and up to date on every machine. If it's not installed, it can't stop a virus. If it's not active, it can't stop a virus. If it's not up to date, it won't recognize a virus. So be sure and use an antivirus on every machine. Now let's move on to anti-spyware. Anti-spyware is closely related to antivirus. As a matter of fact, a lot of antivirus software packages have anti-spyware built into them. Spyware is malicious code that collects information about a system. It may change some system settings, but what it does is it collects information and then it sends that information off to a remote site. Anti-spyware can prevent that code from running. It can also assess a system and help the user to determine if spyware is present and the level of threat that that spyware represents. A discussion on digital security wouldn't be complete without a discussion on firewalls. Software firewalls should be installed and active on every machine. Firewalls are the traffic cop of network traffic. They control the flow of data into and out of a PC, and they help prevent attacks or to mitigate attacks once they occur by recognizing suspicious activity. Make sure that you use a good quality software firewall on every PC. Digital security also wouldn't be complete without user authentication. There are three main ways to authenticate a user. There's the what you know, username and password, what you have, like a security token, or what you are, biometrics. You can combine these factors to increase your security level. Speaking about authentication, let's talk about passwords. The strongest passwords are random strings of letters, numbers, and symbols, but they're kind of hard to remember. The weakest passwords are whole words, consecutive numbers, or easily guessed passwords, like a birth date or an anniversary. Now, there are some methods that you can use to help teach strong password protocol for your users. An example of a protocol that you can use to train users to get strong passwords is the following. So think of a phrase that can be remembered. How about IT security is essential? The first step would be to remove all the spaces. So it'd be IT security is essential. Then you replace some of the letters with numbers and symbols. And then you can replace some capital and lowercase letters with the opposite. And you end up with a really secure password that is easier to remember than random letters and numbers. So how secure is your system? It all begins with you. Now that concludes this session on IT security measures. We talked about the principle of least privilege. We talked about the importance of user education, and we concluded with some digital security measures. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we will do some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on common security threats. Today we're going to discuss directed security threats, and then we will move on to security threats that are more along the lines of opportunity attacks. And with that, let's go ahead and begin this session. I'm going to begin by stating that not all attacks fall into a neatly confined category. Many times, different attacks are combined to increase their effectiveness. Now let's move on to directed security threats. Now, directed security threats are those attacks that are intentional in nature. And the first one that we'll mention is shoulder surfing. That is where someone is looking over your shoulder in an attempt to gain access to information that they're not supposed to have. That's where they watch you type in your password or your PIN. And as a side note, the user doesn't need to be present for shoulder surfing to occur. You can just leave your PC running without a screensaver. Then there's social engineering. This is where social pressure is applied to get a user to divulge information or secrets. Social engineering can occur in person, over the phone, through email, fake memos, so on and so forth. Anything that tricks the user into divulging information that they shouldn't. Now there are several different types of social engineering attacks. The first one we're going to mention is phishing. Phishing is an attempt to get the end user to divulge sensitive information, as in usernames and passwords or bank account numbers. Phishing always occurs through electronic media, through email or through websites. Which brings us to pharming. Pharming is closely related to phishing, but it can be more passive in nature. Pharming specifically uses a web page or site to glean sensitive information. The attacker develops a fake website and entices the end user into putting in their credentials, and then the attacker gleans that information. Now let's move on to opportunity security threats. These are more along the lines of threats by opportunity. They exploit weaknesses and vulnerabilities. And the first opportunity security threat we're going to mention is malware. Malware is a broad category. It's usually defined as malicious software that has the intent of causing harm. But it can also describe legitimate code that is written poorly. And it's so broad that it actually covers any code-based security threat. The first one that we're going to mention is rootkits. Rootkits are stealth software that take over the root account, the administrative account. Rootkits attempt to hide their presence from the end user and antivirus through its authority level. Rootkits can be extremely difficult to remove because of their level of access to the system. They may actually overwrite the boot sector so that you can't remove them easily and need to actually reformat the whole hard drive. Another type of malware is spyware. Spyware is software that installs itself with the intent of collecting user data or information on habits without the user's consent. It's often configured to collect this information and then send it to a remote site at a specified time. Or it can just store it in a hidden file and wait for the attacker to come by and collect it. It has to have a host file in order to operate. When the host file is run, the virus is executed, and then whatever payload is there is also executed. Now, there are different types of viruses. There's a program or application virus, and they attach itself to a program or application, of course. There's a boot sector virus. Now, this attaches itself to the boot sector of the PC. When the PC boots up, the payload is delivered. There are polymorphic viruses. They attempt to hide their presence by changing its signature on a regular basis. There are stealth viruses. That would be like your rootkit. Then there are multi-partite viruses. They combine several components into one package. None of the components on their own are effective. Now, viruses can combine several of these into one package, and it would still be called a virus. Now, worms are different than viruses. Worms are malware that do not need a host file. They exploit network resources and services to propagate and to move. They are self-replicating, unlike viruses. Worms mainly consume network resources, often resulting in a down network. Now, Trojans are malware that hides its purpose by disguising itself as something that the end user desires. They often come in games, free games in particular. The end user gets tricked into downloading the Trojan, and the virus package is delivered. This is often the attack vector that is used to establish botnets or zombie nodes. Now, that concludes this session on common security threats. We briefly discussed directed security threats and then threats of opportunity. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we will do some more soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on securing the workstation. Today we're going to discuss password policies, user account management, and other workstation security measures. And with that, let's go ahead and begin this session. We begin by talking about password policies. Now, the first password policy that you should have in place is requiring passwords. Kind of silly, but you should require them. All workstations should be set to require passwords to access the operating system. These passwords authenticate the user and create accountability. It also helps to prevent unauthorized access. Now, your password policy should encourage setting strong passwords. The strength of a password is highly dependent upon the number of characters, because the number of characters in the password are the exponent of the strength. Using a mix of characters, letters, numbers, and symbols can create up to x to the 84th power worth of combinations, x being the number of characters, minimum character length. You should also restrict the use of common names and easily guessed passwords, and your policy should be able to handle that. Other password policies that should be considered include the aging of passwords. Passwords that don't expire become ineffective, and the repeating of passwords. If a password can be repeated too often, they also become ineffective. Now let's move on to user account management. The first thing about user account management is that you should restrict the user account permissions. You should use the principle of least privilege. Only grant as many privileges as are necessary to get the job done. Even administrators should be restricted to only their necessary level. And administrators should have a separate account for normal workstation activity. Another thing to keep in mind is don't manage users, manage groups. Users should be created for authentication and then placed into groups. Groups are a whole lot easier to manage than individual users. The groups that you should consider implementing would include administrator groups, power user groups, standard user groups, and guest user groups. Guest accounts should only be activated on a temporary basis, and the default should be not to have a guest account on a workstation at all, and only enable it on a temporary basis. Now let's move on to other workstation security measures. The first topic under this heading is that your policy should be to always change default username and password. Defaults are easy to exploit. If it comes with a default username and password, then it can be looked up and you could be exploited. You should also have a policy in place that requires screensavers with password locks. This makes it more difficult for somebody to walk up to an unused workstation and get into your system. And as a policy, all of your workstations should have the auto run feature disabled. This helps to avoid the easy spread of malware. This requires that the user actually interact with the workstation to install software and applications. Now that concludes this session on securing the workstation. We covered password policies, user account management, and then a brief discussion on some other workstation security measures. Now on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on data disposal and destruction methods. Today we're going to be talking about how to dispose of data on hard drives. And the topics will be standard format versus a low-level format, hard drive sanitation methods, and the physical destruction of hard drives. And with that, let's begin this session. So we need to begin this discussion by talking about what your organization's policy is. When hardware is being replaced, it's imperative that sensitive data is destroyed on the outgoing hard drive. A lot of companies have policies in place on what must occur to the drive and other storage media in order to ensure that their sensitive data does not leave their control. If your organization doesn't have a policy regarding this, then you should sit down with senior management and develop one. That is to ensure that their sensitive data remains under their control. Now let's discuss the difference between a standard format and a low-level format. Most of us are familiar with the standard format, and the standard format usually comes in two forms, the quick and the full. The quick format just prepares a disk to receive a file structure like FAT32 or NTFS. A full format is pretty much the same as the quick format, but it also checks the drive for bad sectors and then marks them. Now, a standard format really doesn't destroy data. It just removes the index for the file structure, makes it a little bit harder to find the files. But there are tools out there that can unformat drives. So just because you used a standard format doesn't mean that the data is gone. There are some tools out there that will write zeros to the disk as it does a format. That is an effective method. Now, low-level formats are different. Most modern drives can only be low-level formatted at the manufacturer. That's because the low-level format actually defines the position of tracks and sectors on the drive. But if you can do it, it is an effective method of destroying data. Now let's move on to hard drive sanitation methods. There are two main ways that you can sanitize a hard drive. You can overwrite or you can use drive wiping. So let's discuss overwriting first. When you delete a file, you'll only actually delete the address, and the file can still be recovered. But if you overwrite the location, you can actually conceal that data. But the problem is that some traces are still left behind, and those traces are enough a lot of times so that the data can be recovered. Just overwriting a file location once isn't enough. That's where drive wiping comes in. First off, you delete the file, and then you overwrite the location multiple times with a changing binary pattern. That is an effective way of sanitizing a hard drive. Now let's move on to the physical destruction of hard drives. The first method that we need to discuss under physical destruction is the degaussing tool, or the electromagnetic method. Now, data is magnetic in nature, so if you use a really strong magnetic field, you will scramble the data. But traces may still remain, enough so that sensitive data can leave your control. But it is a quick and easy method of destroying the physical structure of the data. Another method is to use a power drill and to drill several holes through the hard drive. In some organizations, this is an acceptable method of destruction. It is also fairly quick and easy, but not as easy as the degaussing tool. Another method for physically destroying the data or the hard drive is to use sanding or grinding. You actually take the hard drive apart and sand or grind off the material that holds the data. This is highly effective, but it is kind of labor-intensive and time-consuming. Now, you might want to consider shredding the hard drive. If you use a heavy-duty industrial shredder, it will completely destroy the drive and make any data unrecoverable. It's really easy to do, but it can be costly if you invest in the shredder yourself. So you might want to consider using a shredding service that offers that capability. That can make it more cost-effective, and it will ensure that your data does not fall into the wrong hands. Now that concludes this session on data disposal and destruction methods. We talked about standard formatting versus low-level formatting. We talked about some hard drive sanitation methods and then moved right into the physical destruction of data. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on steps you can take to secure a small office, home office network. Today we're going to be talking about security methods that are common to both wired and wireless networks, how to secure a wireless network, and then some steps that you can take to secure your wired network. And with that, let's go ahead and begin this session. We begin by talking about some aspects of security that are common to both wireless and wired networks. Now, whether wired or wireless, you should have some security in place. And that security, it is up to you to enable. Equipment manufacturers are in the business of selling networking equipment. And it's easier to sell it if it's easier to set up. What that means is that as a default, most equipment does not come with security enabled. So it is up to you to enable that security. Part of what that means is that you should always change default usernames and passwords. The defaults are easy to find out, and that makes your network unsecure. If an attacker can gain entrance to the administrative level of a network, then it's no longer your network. You might want to consider enabling MAC filtering. That's media access control. That's because each node theoretically has a unique MAC address. MAC filtering means that you put in the MAC addresses for each authorized node. Filtering reduces the opportunity for unauthorized access. Now, this is not a sure process, as there are ways to spoof a MAC address. You can also assign static IP addresses as another method of securing a network. This makes it a little bit more difficult for an outside attacker to gain entrance if each node is assigned a specific IP address, as opposed to relying upon DHCP. It does make it a little bit more difficult to manage the network, but it does make it that much more secure. And if you do assign static IP addresses, make it your IP address. Don't use the default IP addressing scheme. Now let's move on to things that you can do to help secure a wireless network. The first item under discussion is changing the SSID, the Service Set Identifier. That's the name of the network. It doesn't necessarily add to security in itself, but many default SSIDs is actually the model number of your WAP, your wireless access point. Most WAPs have some weaknesses in them that can be exploited, so if an attacker knows what model you have, they might be able to exploit it easier. So change the SSID to something of your choosing. Another thing that you need to consider is your antenna and WAP placement. This also doesn't necessarily add to security in itself, but it can help. Now, WAPs use radio broadcasts. You need to make sure that it's in a central location and that it has the coverage that you need. But you don't want to put it somewhere where you're going to leak signals to an area that you don't want. So placement consideration is necessary. Along with that placement consideration is your radio power levels. How far does your signal reach? You even know that? Can somebody sit outside in your parking lot or your driveway and hijack your signal? Most WAPs do allow for the adjustment of the power level for the radio. So you should check your perimeters to see how far your signal is actually going. Now, the most important part of securing a wireless network is setting the encryption level. If you want to have a secure wireless network, then encryption needs to be in place. You need to set it at the highest level that is supported by all machines. Now, if that highest level is WEP, Wired Equivalent Privacy, then you need to replace some equipment. Do not use WEP as your only encryption. It's been broken for a long time. You really should use WPA2 with AES as your encryption standard. Now let's move on to things that you can do to help secure a wired network. The first thing that you should do to secure a wired network is to disable any unused ports on your equipment. If an attacker can plug into a port and gain access to your wired network, you're sunk. It's no longer your network. Which also brings us to the next step, physical security of the equipment. You need to limit the physical access to the network switches and routers. You also need to limit physical access to wiring closets and punch-down panels. If an attacker can easily get physical access to network equipment and wiring, then it's not really your network to control. Now that concludes this session on how to secure a small office, home office network. We talked about some security measures that you can take that are common to both wired and wireless networks. Then we talked about wireless network security. And then we briefly discussed some things that you could do to help secure your wired network. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do some more soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the basics of mobile devices. Today we're going to be talking about some of the basic features of the mobile operating system and some things that differentiate the hardware of the mobile device from a standard IT device. And with that, let's begin this session. We begin by talking about basic features of the mobile operating system. And as I'm sure you're aware, Google's Android and Apple's iOS operating systems make up the vast majority of the mobile marketplace. There are other players, but they don't have near the reach and influence of Apple and Google. So let's start by talking about the Android operating system. It's open source. The operating system can be modified by anybody within the licensing agreement. Android can be placed on any hardware, so vendors can create their own Android devices. Apps and programs are available for Android all over the place. Google Play is the largest source, but you can get them from other sources. Apple's iOS, on the other hand, is closed source. It's only available from Apple and cannot be modified. You are limited in your hardware options to only those that are supplied by Apple. And you can only get apps from the Apple App Store. Now let's move on to a brief discussion of Windows. Windows does have a mobile operating system. It's closed source as well. It's only available from Microsoft. But your hardware options are more than what's available with iOS, as vendors can create their own devices. Your only readily available source of apps is from Microsoft, though. So it's kind of a combination of the open source and the closed source ecosystem. So let's talk about common operating system features. And we begin with screen orientation. Mobile devices can determine the orientation of their screen, either landscape or portrait, through the use of an accelerometer and/or gyroscope. That means as you turn the screen sideways or upright, it'll flip so that the orientation remains correct. All modern mobile devices have GPS capability built into them. That means they have global positioning system capabilities. This allows the device to know where it is, and some apps will use this to improve their functionality. Now let's talk about geo-tracking. It's similar to GPS, but it uses cell towers to track and log device movement. Now, if geo-tracking is enabled, digital forensic specialists can use this information to track the movement and history of a device. Some apps are available that make this tracking easier, and a lot of parents actually enable geo-tracking on their children's phones so that they can tell where their children are. Almost all mobile operating systems have a way of calibrating their screens. This is not the issue that it once was, but every once in a while a touchscreen may need to be recalibrated, so you should follow the device's instructions on how to do this. Now let's move on to some of the differences between mobile devices and their larger cousins. Now, mobile devices provide a smaller form factor for the user. That's what makes them mobile. This smaller form factor has led to some changes in the hardware used from that in their larger cousins. Now, one of the first differences in mobile devices is they usually don't have field serviceable parts. And because of that, they're difficult to take apart unless you have specialized equipment. Most of the components that make up a mobile device are soldered in place. Unfortunately, that's becoming more common in some laptops, especially the Ultrabooks. Also, with a mobile device, they are not upgradable. What you bought is what you get. Now, all mobile devices do come with some form of solid-state drive. That's because a spinning disk would not be suitable for a mobile device. They just couldn't take the shock. Almost all mobile devices come with a touch interface, and that comes with several things involved. Most of these touch interfaces can sense when they're touched in more than one place. This allows for the pinch and zoom functions on mobile devices. Mobile devices also have touch flow. That means that they can sense when a user has moved their finger along the screen. This allows for the dragging of objects and the scrolling of the screen. Now that concludes this session on the basics of mobile devices. We talked about some basic features of the mobile operating system and some of the hardware differences that make a mobile device a mobile device. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on the basics of mobile device networking and synchronization. Today we're going to discuss basic network connectivity for mobile and then mobile device synchronization. And with that, let's begin this session. So we begin by talking about basic network connectivity for the mobile device. Now, many mobile devices can take advantage of cellular data networks, whether that be 3G, 4G, or LTE. As the user, you need to know how to enable or disable this connectivity for when it's necessary, as in when you're traveling by plane. All of the operating systems that have cellular connections allow for the enable and disable function to be done from the settings area of the operating system. Some mobile devices also allow the user to enable or disable cellular networks from their home screen. Check with your documentation for the correct process for your mobile device. Another type of network connectivity for the mobile device is Bluetooth. A lot of them come with Bluetooth networking. Now, how do you do Bluetooth networking? Usually it's from the settings page on your mobile device. First off, you enable Bluetooth. Then you enable pairing, and then you find the device for pairing. It usually comes up on the screen. Enter the appropriate PIN code when requested, and then test for connectivity. And while there may be some differences in the process, the basic steps remain the same. Now, one of the advantages of mobile devices is the ability to send and receive emails while on the go. As long as the user has an internet connection, email is possible. Some of the things that you need to know before you can utilize this function are the proper email configuration requirements. You need to know your SMTP, your Simple Mail Transfer Protocol. That's for sending emails. You need to know which protocol your service provider requires for receiving email. Is it POP3 or IMAP? You also need to know the fully qualified domain name for the email provider, both for the SMTP server and the incoming servers. You should also know what ports are being used for SSL, and these are determined by the email provider. So some common port settings for email. Well, SMTP has a default port of 25. SMTPS, which is the secure version, is 465. POP3 uses port 110, and POP3S uses port 995 by default. IMAP uses 143, and IMAP-S, secure, uses port 993. The default configuration for Gmail would be pop.gmail.com on port 995 for their POP3 server. Their SMTP server is located at smtp.gmail.com, and it's usually on port 587. And the security level is TLS, that's Transport Layer Security. Now let's move on to mobile device synchronization. Now, each operating system uses its own method to synchronize data. You need to refer to your vendor for the specific process. Almost any type of data can be synchronized across a mobile device to their larger cousins and vice versa. A lot of people synchronize their contact information, programs, email, pictures, music, and videos. But you're not just limited to that. Now, synchronization provides protection against lost equipment by providing a backup copy. It also allows for the free movement of data and keeps it current. Mobile device operating system providers have their own apps for synchronization. The app must be installed on the PC, so you should follow the vendor's instructions. Now, there are several different connection types for synchronization. A lot of them allow for wireless or cellular synchronization. That's synchronizing to the cloud. You can also synchronize across wireless networks. With a lot of devices, you can also sync using a USB cable. With some devices, you can use Bluetooth networking to sync with a PC or another mobile device. It's not as common anymore, but it's still an option for some mobile devices. In the past, you could use infrared to sync devices, but that's no longer a current method. Now that concludes this session on basic mobile networking and mobile device synchronization. We talked about basic network connectivity for the mobile device and some synchronization methods and why you should synchronize your mobile devices. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on how to secure a mobile device. Today we're going to talk about some methods that you can use to help secure a device against loss or theft, and how you can help secure it against malware. Now let's go ahead and begin this session. Now we begin by talking about some methods that you can use to help secure a mobile device against loss or theft. Since their inception, loss and theft has been a concern with mobile devices. Just about everyone has either lost one or had one stolen. Now, in the early years of cell phones, the major concern was that your cell phone was going to be used to call some foreign country or toll numbers, and you'd rack up a huge bill. Now, with the advent of smartphones and tablets and the portability of data, much more is at stake, so you should take steps to secure your mobile device. Your first line of defense is the passcode lock. It's usually a 4-digit code that must be entered to unlock the phone, although they are using other methods now as well. Many operating systems also have failed logon restrictions that you can enable. As a user, you get to determine which actions occur after so many failed login attempts. Many mobile devices also have locator applications. These use GPS and geo-tracking to pinpoint the location of a device. It's especially useful in cases of theft, although I usually don't recommend confronting the thief. And the last part of your first line of defense is your remote backup application. Make sure that you always have a current backup of your mobile device in case you cannot recover it. Now, your last line of defense is the remote wipe. Many phones and mobile devices are set up so that they can receive a signal from the user that will wipe all data remotely. You should only use this if you cannot recover your device, but it will ensure the privacy of your data. Also included in this last line of defense is your remote backup application. Just like on your first line of defense, always make sure that you have a current backup of your data. Now let's talk about how you can help secure a mobile device against malware. Now, as the mobile device arena advances, more and more malware is being developed for these devices. Originally, there wasn't much demand for malware on the mobile device. After all, what could you hope to recover? But with the rise of the smartphone and the tablet, guess what? The stakes have also been raised. Your first line of defense in the mobile device arena is user education. You should teach and practice safe mobile device habits. Don't visit shady websites or whatnot with your mobile device. Patching your operating system and keeping current on updates is another portion of your first line of defense. This can mitigate many threats and vulnerabilities and helps to reduce the threat of malware. You should only acquire apps from a trusted source. Be aware that not all apps are created equal. You're much more likely to download malware on an Android device than you are on an Apple iOS device. Again, your remote backup application is part of your first line of defense. Backing up your data is always crucial. Your second line of defense on the mobile device is antivirus. Why is it your second line of defense? Well, because on the mobile device, the antivirus has to be configured and developed for each device and each operating system. This makes it a little bit harder to come by and not as advanced as desktop antivirus. So you should do your research before installing an antivirus app to make sure that it will be effective for you. Now that concludes this session on how to secure a mobile device. We discuss some methods that you could use to help secure a mobile device against theft or loss, and how you could help protect a mobile device against malware. Now, on behalf of PACE IT, thank you for watching this session, and we will do it again soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Troubleshooting Theory. Today we're going to talk about the importance of having a methodology and the 6-step troubleshooting methodology recommended by CompTIA. And with that, let's go ahead and begin this session. So we begin by talking about the importance of having a methodology. And I like this quote by Stone Gossard from Pearl Jam. "My methodology is not knowing what I'm doing and making that work for me." Not everybody can do that, especially not in the tech world. Due to the complexity of modern computing systems, the wise technician will have and follow a troubleshooting methodology. Not having that methodology in place means you're much more likely to waste time and effort and create frustration not only for yourself but also for your end user. Now let's move on to CompTIA's 6 steps to troubleshooting. CompTIA recommends the following 6 steps. The first step is to identify the problem. The second step is to establish a theory of probable causes. The third step is to test the theory of probable cause. The fourth step is to develop an action plan and implement that plan. Step 5 is to verify complete system functionality, and step 6 is to document the process. Now let's discuss each of those steps in a little bit more detail. Identifying the problem. The first thing that you need to be aware of is the symptoms are not the problem. You need to get down to the base problem. That is the thing that is causing the symptoms to manifest. And to do that, you should question the user. You need to ask them questions about when it occurred and why it occurred. You should try and determine what has changed. And before you do anything else, you need to make a backup of the system just so you can preserve everything as it is. From there, you establish a theory of probable causes. You make a list of all of the probable causes, then using your technical knowledge, prioritize that list. Your list should have the probable causes listed from most likely to least likely. And by the way, you need to question the obvious. If it's a power issue at the workstation, is the power cord plugged in? Once you have your theory of probable causes, this is where you first consider whether or not you can take care of it or if you need to escalate it to a higher authority. Once you have your probable causes, now you need to test your theory of probable cause to determine if it's the actual cause. Your theory was created off of the most likely probable cause. So you need to figure out how you're going to test it. If the theory is confirmed, move on to the next step. If the theory isn't confirmed, go back to step 2 or step 1 if needed. Once you have determined the actual cause by testing your probable cause, then you need to establish an action plan and execute the plan. Simple problems will probably just need simple plans. But if it's a complex problem, then you may need to write out the plan so that you can be sure to execute it correctly. This is another spot where you can escalate the problem if need be. After you have executed your plan, you need to verify full system functionality. If everything works, great. This is where, if it's applicable, you implement preventative measures to prevent the problem from occurring again. If full system functionality has not occurred, well, that's not quite so great. Now you need to go back to step 1. But let's talk about if everything was fully functional. This is where you need to document the process. This is where you document findings, actions, and outcomes. This is so if the problem occurs again, there is a document that'll walk somebody through an easy way to resolve the issue. It also gives a history of equipment and users so that problem children can become known. Another important aspect of this is that both positive and negative outcomes need to be documented. This is so that other people don't make the same mistakes that you might have made. Now that concludes this session on troubleshooting theory. We discussed the importance of having a troubleshooting methodology in CompTIA's 6-step troubleshooting methodology. Now on behalf of PACE IT, thank you for watching this session, and I'm sure we... Hello, I'm Brian Farrell, and welcome to PACE IT's session on troubleshooting motherboards, RAM, and CPUs. Today we're going to talk about common symptoms of problems and some troubleshooting tools that you can use to solve those problems. And with that, let's go ahead and begin this session. We're going to begin by talking about common symptoms of problems. Now, these symptoms that we're talking about today are ones that are caused by motherboard, RAM, and/or CPU issues as a general rule. And the first one we're going to talk about is unexpected shutdowns. Here, the most likely cause is heat. Check the ventilation and clean out the fans. Also check for fan operation. System lockups. Guess what? The most likely cause is heat. Check the ventilation and clean out fans. Also check for fan operation. Now we move on to postcode beeps. This is where you get a series of beeps when you're booting up the system. Now the most likely cause is, guess what? We don't know, because each manufacturer defines their own beep codes. So you need to refer to system documentation to determine the actual cause for the postcode beeps, and/or get a postcode card. If you boot up the system and you got a blank screen, guess what? The most likely cause is your onboard graphics. This is particularly prevalent in systems that have onboard graphics and an add-on card. And what happens is the cord that goes from the monitor to the PC is plugged into the wrong port. If your system isn't keeping time or date correctly, the most likely cause is a low CMOS battery. The CMOS battery is the timekeeper for the system and retains user adjustable settings in BIOS as well. So if your system attempts to boot to the incorrect device, the most likely cause is an incorrect BIOS setting. BIOS has the incorrect boot order setting. You need to correct that to get it to boot to the correct device. If your system is suffering from continuous reboots, that can be hardware or software related. If you've just installed new hardware, then the most likely cause is a wrong driver. If you haven't just installed new hardware or it is the correct hardware, then the most probable cause is an update to the operating system or an application that you use, or an application that executes on boot up. Absolutely no power? Well then guess what? The most probable cause is the power supply. Check the plugs for the power supply. Make sure they're plugged in where they're supposed to be. And then check the settings for the power supply voltages. Suffering from overheating? Then the most likely cause is either poor ventilation, inadequate cooling, or your system has been overclocked. Those are three things that you can look at that are highly probable causes of overheating. Loud noises? The most likely cause is dirt. As fans become dirty, they need to work harder to cool, which will increase the noise level of your system. If your PC is suffering from intermittent device failure, well then the most likely cause, well, this can be a heat issue, but it also might be caused by bad RAM. If the ventilation is okay, then run the memory diagnostic utility on your next reboot to see if you have some bad RAM. How about when your fans spin, but there's no power to other devices? Well, then your most likely cause is that there's no power to the CPU. This is caused when the power regulator on the motherboard has gone bad. That's because the fans don't require the CPU to run, where every other device really does require the CPU to have power. Have smoke escaping from your PC? Well, your most likely cause is the power supply. It's possibly a short in the power supply or the wrong voltage setting on this power supply. In either case, you've got a problem. How about a burning smell or sparks? Guess what? That's also most likely caused by the power supply. It's closely related to smoke. Another possible cause is a short caused by nicks or cuts in the wiring insulation. How about the blue screen of death? The most likely cause is either a faulty motherboard or RAM if it's not an other hardware-related issue. Now, as a general rule, electronics don't like it when you let the smoke out of them. Remember, try and keep the smoke inside of your PC. Now let's talk about some troubleshooting tools that you can use to troubleshoot motherboard, RAM, and CPU issues. The first tool is a screwdriver. Why? Because it allows you access to inside the case so that you can look at the motherboard, the CPU, and the RAM. A multimeter is another awesome tool for troubleshooting these items. It allows you to check and make sure that everything's getting the appropriate voltage. I would recommend using a fairly high quality multimeter, as not all multimeters are created equal. Another tool that you may want to consider acquiring is a power supply tester. This simulates the load on a power supply and displays voltages. It makes it easy to test a power supply when you're having problems. It's also useful for testing a power supply when you don't have a motherboard. A post card is another handy addition. It's an adapter card that plugs into a PCI or PCIe slot. It displays a code that will point out when and where a post failure occurs. Some motherboards have postcards built into them, but not all of them, and you might want to consider getting one so that you can learn the codes and be familiar with them. Now that concludes this session on troubleshooting motherboards, RAM, and CPUs. We talked about common symptoms of problems and then some troubleshooting tools that you can use to help resolve those problems. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one real soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on troubleshooting hard drives and RAID arrays. Today we're going to talk about common symptoms of problems and common tools to fix those problems. And with that, let's go ahead and begin this session. We're going to begin by talking about common symptoms of problems. And the first one we're going to discuss today is read-write failures. The most likely cause of read-write failures are bad clusters. The failure rate tends to be low for bad clusters, but they do still occur and are much more likely as the system ages. Read-write failures are usually caused by a physical defect on the drive. Slow performance of a hard drive or RAID array is another symptom that you will more than likely come across. The most likely cause is fragmentation. The more fragmented a drive is, the more seek time is required to retrieve the requested files and/or data. One that you hope never to come across, but more than likely you will, is a loud clicking noise. The most likely cause is the read head contacting the platter, and that's not a clock ticking. Well, it is actually, because now you're on the clock. You have a limited amount of time to get that drive replaced before it fails. You need to get it backed up and replaced as soon as possible. Failure to boot or operating system not found errors can be caused by a hard drive or a RAID array. The most likely cause is that you're booting to the wrong drive. You should check the BIOS setting, but it can also be indicative of an operating system error. Every once in a while, you'll get a drive not recognized error. And the most likely cause is dependent upon which kind of drive it is. For an external drive, it will more than likely be a file system or partition issue. For an internal drive, it's going to be caused either by a BIOS setting or a cabling issue. Now let's move on to some RAID-specific symptoms, like RAID not found. The most likely cause for that is an incorrect driver. Most often, RAID is set up as an external enclosure with their own drivers. so you need to make sure that you use the correct one for your operating system. If your RAID was working and then the RAID stops working, the most likely cause is a disk or disks failure. In a RAID 0, this is a big problem, as your data will be difficult to recover. In other RAID setups, that just means it's time to find the failed disk and replace it. It's not common that a hard drive or a RAID array can cause a blue screen of death. The most likely cause for this is the incorrect driver. So guess what the corrective action is? Use the correct driver. Now let's talk about some common tools that are used in troubleshooting hard drives and RAID arrays. Guess what? Your first tool is a screwdriver or a set of screwdrivers. These get you into the case or into the enclosure so that you can remove a drive. Speaking about removing a drive, there's also external enclosures. This allows a suspect drive to be accessed from an operational system for diagnosis and repair. Another tool is check disk. Actually, it's a utility, but it's a common tool that's used to fix read and write failure and operating systems not found issues. It checks the physical surface of the disk and can do repairs and recovery in certain cases. Then there's the format utility. It's commonly used to fix an incorrect file system structure. Then there's also defrag, which is used for defragmentation of a hard drive to improve the performance of a hard disk or RAID array. And the final tool that's used when troubleshooting hard drives and RAID arrays is file recovery software. This is used to recover data from a drive that has had a problem. Now that concludes this session on troubleshooting hard drives and RAID arrays. We talked about common symptoms and then common tools used to fix or troubleshoot hard drives. Now on behalf of PACE IT, thank you for watching this session, and I'm sure I'll do another one real soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on troubleshooting video and display adapters. Today we're going to talk about the 6-step troubleshooting methodology and common symptoms of video and display problems. And with that, let's go ahead and begin this session. We're going to stop with a refresher on the 6 steps of troubleshooting methodology as provided by CompTIA. The first step is to identify the real problem. To do this, you need to ask questions and whenever possible, witness the problem personally. And remember, your troubleshooting can only be as effective as your identification process. Once you have identified the problem, then you need to establish a theory of probable causes. After you have established your theory, then you need to test the theory to determine actual cause. Once you've determined the actual cause, then you need to establish a plan of action and implement that plan. Once the plan has been acted upon, you should verify full system functionality, and once you're all done, be sure and document all findings, actions, and outcomes. And with that, let's move on to common symptoms of problems involving video adapters and displays. The first symptom we're going to discuss is VGA mode. The most likely cause is an incorrect driver. VGA mode is the default safe resolution and may be seen when a video card has been replaced and the incorrect driver is in play. Usually if you update the driver, VGA mode goes away. How about no image on the screen? Well, the most likely cause is either that the monitor is not plugged in or receiving power, or the backlight on a flat panel has failed. If so, replacing the monitor is often more cost-effective than repairing the backlight. How about an overheat shutdown situation? The most likely cause is poor ventilation. Today's graphics cards run hard, read that as hot, so they need really good airflow. Improving the ventilation usually will resolve this issue as far as the graphics adapter goes. Dead pixels? Well, that's a symptom that's caused by, well, dead pixels. They're not that uncommon. Most displays have at least a few. Not a big deal. If it gets to the point where it annoys you too much, then replace the monitor. Sometimes the pixels may just be stuck. You can try different methods to unstick stuck pixels. There are some YouTube videos that'll flash the screen in an attempt to unstick stuck pixels. Is your display suffering from artifacts? Well, that's caused by either an overheating graphics card or a bad DVI interface. Either one of those will cause artifacts on your screen. Another symptom that you'll sometimes come across is that your color patterns are incorrect. The most likely cause is poor calibration of the color. Most people won't notice this problem, but if you do, or it becomes too big of an annoyance, you can manually adjust your color calibration. I will warn you, it can be tedious and difficult to get it right. They do make some software packages that ease that, but that's up to you. If your video display is suffering from a dim image, then the most likely cause is dependent upon what kind of monitor you have. Either your settings are too low, as in they've been turned down, or the backlight has failed in a flat panel display. If you're using a CRT display, they do dim with age. If the image becomes too dim, then it's time to replace the monitor. If your screen flickers, the most likely cause is a low refresh rate. And that's only an issue with a CRT monitor. If you're using a CRT and you have a flickering image, increase the refresh rate to 72 Hz or higher to get rid of that issue. If your display is suffering from a distorted image, the most likely cause is using the wrong resolution. Modern monitors have a native resolution. The fix to a distorted image is usually to return to the native resolution. Is your display suffering from discoloration? Well, then the most likely cause is magnetic or electromagnetic interference. This again is usually an issue with CRTs. If you move the monitor away or the other electrical devices away from the monitor, that problem usually goes away. Your monitor and/or graphics card can cause a blue screen of death if an incorrect driver is being used. It's not very common, but it may still occur at times. Now that concludes this session on troubleshooting video adapters and displays. We talked about the 6-step troubleshooting methodology of CompTIA and common symptoms of problems that might occur with video adapters and displays. Now, on behalf of PACE IT, thank you for watching this session, and I look forward to doing some more. Hello, I'm Brian Farrell, and welcome to PACE IT's session on troubleshooting networks, the wired kind. Today we're going to talk about common symptoms of problems that you might experience on a wired network and some tools that you can use to resolve those problems. And with that, let's go ahead and begin this session. And of course, we're going to begin with common symptoms. The first symptom that we're going to talk about is when you have no connectivity. In that case, the most probable cause is with the NIC, the network interface card. You should check your link lights, cables, and connections to help determine what caused the no connectivity symptom. If you have connectivity, but you only have an AP/IPA address, then the most likely cause is with your DHCP server. What that means is that if your address begins with 169.254, then you should check to ensure that your DHCP server is functioning properly. If you have limited connectivity, the most likely cause, well, that all depends. If you can't connect to a local device, check the device that you can't connect to. And if you can't connect to other networks, then you need to check the router. Those are causes for limited connectivity. If you only have local connectivity, what that means is that you can't connect outside of your network, then the most likely cause is with the router or your settings. A default gateway is required to reach other networks, so the setting could be wrong on either the router or on your PC, or the router can be offline. If you're experiencing intermittent connectivity, well, then the most likely cause, again, this is a depends. It could be a bad cable, one that has a short in it. It could be a NIC that is about to go down or fail, or it could be a bad port on the switch or router. You're going to need to do a little bit more testing to determine the probable cause. If you have an IP conflict, the most probable cause is a misconfigured address. This doesn't happen very often when you're using DHCP, but it's a lot more likely if you're using static IP addressing. In this case, the first PC on is the one that gets to keep the address. The next one on will not be allowed. Now let's talk about some tools that you can use to solve these network problems. The first tool that we're going to talk about is the loopback plug. This is used to check the functionality of your network interface card. It plugs into the NIC, and when you ping, it sends a signal out the NIC and then right back in. It's a great tool to use when you need to troubleshoot a NIC. Now let's talk about some cable tools. And the first one we're going to talk about is a cable tester. Now these are used to test the integrity of the cable. They can tell you whether or not they're wired correctly or if there's a short in the cable. Toner probes also come in handy, especially when you have a cable that has a short. This way you can trace the cable. It injects a signal into the cable and then listens for that signal. Punch-down tools are great for when you need to replace a wire into a punch-down block. These actually place the wires into the block and trim them neatly. Wire strippers will also come in handy because if you need to replace or repair a cable, then you're going to need to strip the jackets off of them. And that brings into play the crimper. These are used to secure the cable into the proper termination ends. Another useful tool to have. Now let's move on to some software network utility tools that you can use to troubleshoot a network. And the first one we're going to talk about is ipconfig. Now this is used to review the IP configuration on a given node. It'll give you all the information, depending upon which switch you use in the command, about the network configuration for that node. Ping, well, it uses ICMP echo requests to test for basic connectivity between two nodes. It's a great way to tell if you can get from one location to another in a quick manner. Tracert uses ICMP echo requests to map the path between two nodes that are on separate networks. It asks for and receives a response from routers and tells you which routers your packet is going through. Netstat is used to identify which applications or network connections are consuming network resources. This allows you to see what's using up the resources and might be causing congestion on your network. NBTstat is used to troubleshoot NetBIOS name resolution issues. Net, well, I love this command. It's commonly used to establish a path to a network share. This is what you use to connect to a network share. And sometimes that might be one of your connectivity issues if you can't connect to a network share. Now that concludes this session on troubleshooting networks the wired kind. We talked about some common symptoms of network problems and then some tools that you can use to help troubleshoot, diagnose, and repair those problems. Now on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do another one real soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on troubleshooting networks, the wireless kind. Today we're going to talk about some common configuration issues, common symptoms of problems that might occur on your wireless network, and then some tools that you can use to troubleshoot and resolve those problems. And with that, let's begin this session. So we're going to begin by talking about some common configuration issues that you need to be aware of. We're going to begin this discussion with the SSID, the Service Set Identifier. This is the network's name. It is case sensitive, so a mismatch in the SSID will cause a no connectivity issue. Another one that commonly crops up is security type. A mismatch in the security type will prevent a connection as well. And you need to realize that your wireless access point is what establishes the security type that will be used. A mismatch in the passphrase or security key also means that you cannot connect, and these are case sensitive as well. Now let's move on to common symptoms. The first common symptom that we're going to talk about is no connectivity if it's a new device going onto the network. And the most probable cause in this case is a configuration mistake. Check your SSID, security type, and passphrase to ensure that they are correct. Now let's talk about no connectivity on a device that used to have connection. Well, in this case, the most likely cause is, well, either the WAP or the device may be the issue. You need to check if other devices can connect to the wireless network. If they can, then it's your device. If they can't, then it should be your wireless access point. Now, if your wireless device only has an AP/IPA address, then the most likely cause is your DHCP server. AP/IPA addresses only come into play when the device is set to receive its IP information from a DHCP server, and it doesn't receive it. So you need to check whichever device is being used as your DHCP server and figure out why it's not handing out addresses. Now let's talk about why you might only have local connectivity. Well, the most likely cause is your default gateway. The gateway setting may be incorrect on the device, or the WAP may not be able to communicate with its default gateway. So you need to check that, and that's the most probable cause for only having local connectivity. In a wireless network, intermittent connectivity is caused by the signal strength being too low for a solid connection to occur. You can adjust the placement of the wireless access point or adjust the placement of the antenna to see if you can get the signal strength up. If all else fails, you can turn up the radio frequency power on the WAP. If you have an IP conflict, then the most probable cause is an incorrect IPv4 setting. Static IPv4 addressing may result in duplicate addresses, and the first device on the network wins. So while static addressing is more secure, it can create a problem for you. Now, if your wireless network is experiencing slow transfer speeds, then the most likely cause is signal interference. This may be mitigated by adjusting the placement of the wireless access point, its antenna or antennas, or increasing the radio frequency power setting. You may also reduce interference by changing the channel that the wireless access point is sending on. Now, if your network is experiencing low radio frequency signal, well, then the most likely cause is, guess what? WAP placement or your RF power setting. You can adjust the placement of your WAP to increase the signal strength to your device, or you can turn up the power. If you turn up the power, one of the things that I will caution you about, now balance needs to be kept between your need for signal strength and security. If you turn up the power or adjust the WAP placement so that your signal strength goes beyond your walls, then your wireless network is a little less secure. Now let's move on to common tools. Now we're not going to spend a whole lot of time on common tools for troubleshooting a wireless network, and the main reason is there's not a whole lot of hardware tools for you. And the software utilities to troubleshoot wireless networks are the same as those that are used to troubleshoot a wired network. So you should watch that session if you need more information. Now, on the hardware side of things, you could use a wireless locator. Wireless locators are mainly used to sniff out and find rogue wireless access points, but they can also help troubleshoot wireless networks, as many of these locators can not only find the network, but they can evaluate their radio frequency strength. Now that concludes this session on troubleshooting wireless networks. We talked about common configuration issues, some common symptoms of problems in wireless networks, and then some tools that you can use to troubleshoot and fix those problems. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do some more soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Troubleshooting Windows Operating System Part 1. Today we're going to talk about common symptoms of problems with the Windows operating system, what causes those symptoms, and some tools that you can use to resolve those problems. And with that, let's begin this session. So we need to begin by talking about the Windows operating system. It's composed of tens of millions of lines of code. That's a lot of complexity, and there's a lot that can go wrong. Because of this, it's important that you follow a troubleshooting methodology to reduce your wasted time and to reduce your effort level. So the first symptom that we're going to talk about is the BSOD, the blue screen of death. The symptom is that a critical stop brings up the BSOD. There are many things that can cause the blue screen of death to show up. The nice thing is that it usually provides a hex code at the bottom that you can use to research what the problem is. Tools that you can use to help resolve this are disable automatic restart on system failure, that way you can get the code, and then Microsoft's knowledge base to research the code. Failure to boot. The symptom is that the system will not boot up, and you may or may not get an error. Many things can cause this. There are hardware and software errors, viruses can do this, or it can just be a glitch. The tools that you can use to resolve this include just doing a simple restart, especially if it was just a glitch. Microsoft's knowledge base. You can use last known good configuration from the advanced boot options menu, or startup repair from the same menu, or safe mode from the same menu. If you do safe mode, you can run antivirus and system restore from there. You can verify system files with the system file checker scan now option. Fix boot and fix MBR can be used to fix boot sector issues, and as a last resort, you can restore from a system image. Now let's talk about improper shutdown. The symptom is that the PC shut down with no warning once, but can reboot with no problem. The cause is more than likely just a glitch or a momentary power issue, or your end user just doesn't understand the importance of proper shutdown. Your tools, well, if it's a glitch, there are none. And if it's the end user, well, end user education usually solves that problem. Now, there are other shutdown issues like spontaneous shutdown or restart. And the symptoms are kind of the same as the improper shutdown, but it keeps happening, and it isn't the end user. Causes can include malware, faulty RAM, and a failing power supply. The tools that you can use to troubleshoot this are antivirus software, system file checker with the scan now option, and the Windows memory diagnostic tool. If none of those do it, then you might want to follow the procedures for troubleshooting a power supply. Now let's talk about if your RAID is not detected during installation. Well, your symptoms are you've just installed a RAID array, and it's not initializing on boot up, and it's not available for you to use. The cause is usually a hardware-based RAID with an incorrect driver. The tool used to troubleshoot and fix this problem is the device manager and the process to check and update drivers. Or you can check with the RAID hardware manufacturer's website. Now, if a device fails to start, and the cause for that is usually a bad or incorrect driver, the tool to use is Device Manager, and the process is to check and update the driver. Every once in a while, you'll get a missing DLL message. And the symptom here is that an application fails to load or function, and it gives you missing DLL message. The cause is that the required dynamic link library file, which is reusable code, is either missing or corrupt. Your tools to troubleshoot and recover from this include System File Checker with the Scan Now option. A lot of times that'll reload the proper DLL file. In some cases, it may be necessary to register your DLL file. And to do that, you use the regserve32 command. Whatever you do, do not download third-party DLLs from the internet. That's a common way to actually download and install malware on your machine. Another symptom that we need to discuss is when services fail to start. The symptoms are that some function is affected because the service hasn't started. There are several things that can cause this. The leading cause is that the service that is needed has been set to disable. You can check the system log in the event viewer to see if you can get any hints as to why the service failed to start. Or you can use the service applet. This can also give you insight on the service's behavior. Has it been set to run automatically, or is it in the disabled state? Every once in a while you'll get a compatibility error. The symptoms for this are that the application either doesn't start or it fails to run properly. The cause is that the application is legacy. It's older. It's not that compatible with a newer OS. The tools to fix this include the application log in the event viewer to see if an error message has been logged. A lot of the times this will be there, and it'll tell you that there's a compatibility issue. The usual fix is to run the application in compatibility mode so the operating system mimics an older or prior operating system. A symptom that also commonly occurs is slow system performance. The system is running slower than normal. Causes include too many applications running, not enough memory, or possibly a process or application issue, or malware. All of those can consume your CPU and operating system times. Tools to troubleshoot and resolve this include the Task Manager. Check to see what applications and processes are overly consuming CPU resources. You can also stop the process or lower its priority from here. Now that concludes this session on Troubleshooting the Windows Operating System Part 1. We talked about some symptoms, some causes, and tools. Now on behalf of PACE IT, thank you for watching this session, and we'll do another one real soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on Troubleshooting the Windows Operating System, Part 2. Today we're going to talk about symptoms, causes of those symptoms, and tools to troubleshoot and repair your Windows operating system. And with that, let's go ahead and begin this session. Let's begin this discussion with symptoms, causes, and tools. The first symptom we're going to talk about is your PC boots automatically into safe mode. The usual cause for this is a misconfiguration to the startup process and/or possible malware infection. To check to see if it's a configuration issue, use msconfig to check the startup configuration. And if that's not the problem, then you need to work with your antivirus software and run it in safe mode so that it can remove the malware. Now, if a file fails to open, well, the usual causes include an unknown file extension, or you're missing the appropriate application for the file to open, or the file association has been modified. Tools to resolve this include using the default Programs applet in the control panel and the command prompt to determine what file types are associated with applications. The command to do that is ASSOC space pipe more. Now sometimes when you boot, you might get a message that says missing NTLDR, missing NT loader. This one can be frustrating. Causes include trying to boot from a non-bootable disk. Your BIOS settings may be incorrect. You may have a corrupted boot sector or a corrupted MBR, or your NT loader file is missing or corrupted. Tools to troubleshoot and resolve this include your BIOS settings page to ensure that the boot order is proper. The command prompt, from there you run either fix boot or boot rec with the fix boot option to repair the boot sector, or you run fix MBR or boot rec with the fix MBR option to repair the MBR. And you may need to manually copy a new NT loader file. And I've included the commands here for you. Related to the missing NT loader error message is the missing boot any message. This only occurs in XP, by the way. The symptom is that the PC will not boot and you get this message. The causes are the same as the NT loader, only they involve the boot any file. The tools to fix it are the same as the NT loader, and you can rebuild the boot any file with the boot cfg rebuild command. Now your PC may fail to boot and you'll get a missing operating system message, a missing graphical interface, invalid boot disk, boot MGR not found, boot MGR is missing. Any of those messages all kind of point towards the same thing. All of these involve the fact that your graphical user interface isn't loading. Now the causes for this can be the wrong boot order in the BIOS or a problem with the boot sector or MBR. Tools to fix it include the BIOS settings page, the fix boot or boot rec with fix boot command, the fix MBR or boot rec with fix MBR command. Finally, you might need to run the boot rec with rebuild BCD command. That's the boot configuration data file. Those are in Windows Vista and newer operating system, and the BCD holds the boot parameters for Windows and informs the PC how to load the operating system. Now let's talk about some additional tools for troubleshooting your Windows operating system. The first one that we're going to talk about is the recovery console, or in newer versions, the recovery environment. It's available from the advanced boot option page. To get there, you hold down F8 during the startup process. This provides additional tools to the user for troubleshooting and repairing a PC. You can also use emergency repair disks. These are bootable media that holds a basic operating system that allows access to tools for troubleshooting and repairing systems that will not boot to their own operating system. You may also use regedit. This is a registry editor for Windows operating system. It can be used to modify or create registry entries. Caution must be used here, as a mistake can cause more issues than it resolves. And finally, Windows Vista and newer operating system provide a tool called Startup Repair. This is an option from the System's Recovery option menu that when run can diagnose and automatically repair many boot sector and MBR issues without any intervention of the user. Now that concludes this session on troubleshooting Windows operating system part 2. We talked about symptoms, causes of those symptoms, some tools that you can use to resolve those problems, and then some additional tools that are available for you to troubleshoot and repair your Windows operating system. Now, on behalf of PACE IT, thank you for watching this session, and we'll do it again soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on troubleshooting security threats. Today we're going to talk about common symptoms of security threats, common security tools, and then remediation best practices. And with that, let's begin this session. So of course, we're going to begin this session by talking about common symptoms of security threats. There can be just a few symptoms, or there can be multiples of symptoms that can all point towards a breach or a malware infestation. You may be experiencing uncontrolled pop-ups, browser redirection, even after you reset the home page. You may be getting security alerts from either your antivirus or from the Windows operating system. Unusually slow performance also points towards a malware infestation. You may be having internet connectivity issues because the malware is interfering with the node's connectivity. You might be experiencing unusual PC lockups. Things just freeze on you. That's another indication that you might want to investigate further. Some malware tries to prevent Windows Update from working. This is an effort to continue to exploit a vulnerability. If you start getting messages from antivirus that you didn't know you had installed, then you probably have a rogue antivirus malware infestation. Spam is another indication that you have a problem. It can either be excessive receiving of spam, or it may manifest itself as you're sending spam. Malware often renames system files to make it harder to repair or restore the system. If you have files that are disappearing, that's another indication that there might be a malware problem. If your file permissions change, malware will often change the permissions in an effort to keep you from getting rid of it. If you can no longer get into your email, guess what? Your email's been hijacked by malware. Or if you start experiencing access denied errors to areas of your PC that you could get into before. These all point towards malware being on your system. Now let's move on to common tools that are used in troubleshooting security threats. So your antivirus, anti-spyware, anti-malware software, that's all part of your first line of defense. It can be rolled into one package or application, or they can be separate applications. Your event viewer is a great tool to use when diagnosing security threats. Reviewing the logs can help you determine if there's been any unusual activity taking place, and also help you to determine what the cause is. System restore. You can use this to roll a system back to a previous state, hopefully before the infestation. Your recovery console or recovery environment is another awesome tool that you can use. It gives you access to recovery and repair tools like safe mode and the C prompt. A pre-installation environment, a PE, is also a great way to diagnose and troubleshoot security issues. The pre-installment environment is used during the installation process and in some recovery processes. Using the pre-installation environment in conjunction with antivirus is often called offline scanning, and it is highly effective in removing an infestation. Now let's move on to remediation best practices, the steps that you should take to recover a system that's been infected with malware. So here are the steps. The first step is to identify the symptoms. Be aware of how your system operates so that you can easily identify when a problem has occurred. Once you've identified the symptoms, quarantine the infected system. Remove the network cable and/or shut down your wireless capability on that system. Don't allow it to spread any farther than it already has. At this point, you should disable your system restore. That way you're not creating a restore point that has the infestation. Now you can remediate the infected system. Update your antivirus software, remove the infection, and get things running back to the way they should. Now you should reschedule your scans and your updates. Make sure that you're running scans on a regular basis, and make sure that updates are enabled and active. Now you should re-enable your restore, your system restore, and create a new restore point. And then last, you should educate the end user. Anybody who uses that system needs to be re-educated in proper preventative methods. Now that concludes this session on troubleshooting security threats. We talked about common symptoms that indicate that a problem has occurred. We talked about some tools that you can use to diagnose and recover from a virus infection. And then we briefly discussed the remediation best practices. Now on behalf of PACE IT Thank you for watching this session, and I'm sure I'll do another one real soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on troubleshooting laptops. Today we're going to talk about common symptoms of problems on laptops, and then the proper disassembly techniques that you should use. And with that, let's go ahead and begin this session. Of course, we're going to begin by talking about common symptoms of problems with laptops. The first one we're going to discuss is no display. In that case, the most likely cause is that the display has failed. Causes could also include the laptop is not turned on or a failed video card. Use an external monitor to check to see if it's just that the video card has failed. A dim display. Most likely the backlight has failed. In this case, you should replace the backlight and/or the inverter if it's an LCD display. LED displays don't use an inverter, so you only need to replace the backlight in that case. An easy way to test to see if it's just the backlight has failed is to use a flashlight on the screen. If you can see an image, then the backlight has failed. Flickering display. The most likely cause is that there is a loose connection. Causes could also include the backlight and/or inverter of the display itself, but that's not as common as the loose connection. Sticking keys. The most likely culprit is food. In some cases, the problem may be severe enough that you need to take the laptop completely apart and clean out the keyboard. An intermittent wireless connectivity issue? Well, the most likely cause there is interference. You could be too far from the wireless access point, or there may be a problem with the wireless card or antenna, especially if the laptop has been worked on recently. The battery on the laptop not charging? The most likely cause is that the battery has failed. But it's also wise to check to make sure that you have power coming from the outlet and out to the end of your cord, your power cord for the laptop. Sometimes you'll receive a complaint of a ghost cursor. The most likely cause there is the sensitivity settings on your laptop. They're set too high on the touchpad and/or on the pointing stick. And what happens is if you inadvertently touch the touchpad or the pointing stick, the cursor hops around. Just turn down the sensitivity settings and that'll resolve this most of the time. No power? Well, your most likely cause is that the laptop is not plugged in. Could also be a bad wall outlet, or the power cord or the DC jack on the laptop itself might have failed. But usually it's the fact that it's just not plugged in. In some cases, your end user may complain that their keypad, their numeric keypad, isn't functioning correctly. The issue here is usually resolved by doing end user education on the proper way to enable their numeric keypad. No wireless connectivity? Well, the most likely cause here is that the wireless has been turned off, especially if the laptop had wireless before. But it may also be caused by misconfiguration, which is more common on a new laptop on the network. Closely related to no wireless is no Bluetooth connectivity. And here the most likely cause is that the Bluetooth has been turned off. It may also be caused by a pairing issue if it is with a new Bluetooth device. If the symptom is that you can't display to an external monitor, the most likely cause is that the function key is not set correctly. Toggle the function key used to send video signal to the external connection several times, and that will usually take care of that symptom. Now let's move on to proper disassembly technique. Now research and reading will be a key component of properly disassembling any laptop. Each manufacturer has its own process for assembly, which means they have their own process for disassembly. Research the recommended steps to see the proper way to disassemble and reassemble any given laptop, but there are some common processes that you should follow. Now, I've already talked about researching the manufacturer's recommendations. You may also find some video tutorials on the web on how to take apart a laptop. Once you've decided that it's time to disassemble it, create a plan. Actually write out the steps. It makes it easier to keep track of progress as you can check off the steps as you do them. Once you start, document and label cables and screw locations. Make a map. Use coded containers for the screws. Keep everything organized. It's easier to keep track of pieces if you remain organized. And remember, always use the appropriate tools for the job. Saves on having to buy new screws or cables that have been damaged by using the wrong tools. And remember, always wear your ESD strap. Now that concludes this session on troubleshooting laptops. We talked about common symptoms of problems and then the proper disassembly techniques. Now on behalf of PACE IT, thank you for watching this session, and I'm sure we'll do another one again soon. Hello, I'm Brian Farrell, and welcome to PACE IT's session on troubleshooting printers. Today we're going to talk about common symptoms of problems and then some tools that you can use to troubleshoot and resolve those problems. And with that, let's go ahead and begin this session. And of course, we begin by talking about common symptoms. If your print jobs are coming out with streaks, well, on a laser printer, it's usually a problem with the imaging drum. It has scratches. On an inkjet, you either have dirty or misaligned print heads. If the print jobs are faded, you're low on toner or ink. Ghost images, when they occur, usually occur on a laser printer. The drum may need to be cleaned of residual from a prior very dark print job. If the toner is not fused to the paper, then the fuser assembly needs to be replaced on your laser printer. If you're having a problem with creased paper, that's usually because you're using a heavier bond paper. So send it through the feeder instead of placing it in the paper tray. If the paper is not feeding or not feeding correctly, the paper rollers may be dirty or worn. If you're having problems with paper jams, then you usually have too much debris in the paper path. Remove the jam, then use compressed air to blow out the debris. The symptom of no connectivity is dependent upon what kind of printer it is. If it's a local printer, then it's probably caused by poor cable connections, especially if the printer is powered up. On a network printer, it's usually caused by the printer either not being turned on or the user trying to print to the wrong printer. Every once in a while, a print job will just come out with garbled characters. This is usually caused when the wrong print driver is being used, or it can point towards a cable issue. Vertical lines on a page? Well, in a laser printer, that's caused by either a clogged toner cartridge or a scratched image drum. On an inkjet printer, it's dirty or misaligned print heads. Now, if you're experiencing a backed up print queue, well, that's usually caused by either the printer being paused or the print spooler service being paused. Unpause the printer or unpause the spooler service, and that problem will go away. You may get a low memory error. That means that your image that you're trying to print is too large for the printer. You can either increase the memory in the printer or reduce the resolution of the image. An access denied error is usually caused by the user not being authorized to print. If the printer just will not print, well, then you need to look to see if it's plugged in and turned on. Is it online or offline? Those are common things that you can look at to fix that problem. If color print jobs come out in the wrong colors, then it's usually because the toner or ink cartridges are in the wrong places inside the printer. If you're unable to install the printer, well, then you're not using the correct user account or you're not authorized to add hardware. If you receive error codes, well, the causes may vary. You need to check with the printer documentation to determine what the probable cause for error codes. R. Now let's talk about some tools that you can use to troubleshoot and repair printers. The first one we're going to talk about is the maintenance kit. Laser printer maintenance kits come with pickup and separator rollers, transfer rollers, and fuser assemblies. These need to be replaced on a periodic basis to ensure the proper function of your printer. Now with inkjet printers, most of them don't come with actual maintenance kits because it's actually more cost effective to replace the printer. Another tool that you can use is the toner vacuum. This is a specialized vacuum for cleaning up toner spills. You can often use a high quality vacuum with a HEPA filter and it will do the job just fine. Compressed air is another tool. Next to the maintenance kit, it's a printer's best friend. Accumulated paper dust and debris can cause havoc with print jobs. Periodically blowing out the inside of the printer is a wise thing to do. It'll prevent a lot of problems from occurring. Another tool that you can use is the printer spooler. This is a service that establishes and maintains the print queue. Each PC has its own spooler. Now that concludes this session on troubleshooting printers. We talked about common symptoms of problems and then some tools that you can use to diagnose and fix your printer. Now on behalf of PACE IT, thank you for watching this session and I look forward to doing some more.